This specialization is designed for three types of people. The first set of people who are thinking about pursuing a degree in either business, finance, or an applied discipline. It'll be extremely useful in terms of giving you exposure of what may come down the road. The second audience is people who are at work, want to learn finance to do better at their job. And the third audience is actually not a distinct audience, but an audience that belongs to the first two. It'll help you understand how to make personal decisions in life, which we always have to do, regardless of age these days. I hope you take this specialization, and I hope you learn a ton from it. See you. Hi, welcome back. Today is the first day, or first week actually, of the class, and I talked about the various aspects of the class the previous session. But just to give you a sense of my style, I'm hyper, I'm nuts, I love this stuff, so I will tend to be myself with you, as if you're in the room with me, and I hope that's actually good for your learning rather than interfering. And I talk about life and so on as we go along, and the good news is you can always skip parts you don't enjoy, whereas if you were in the class you have to suffer me throughout the class. So what I'm going to do today is I'm going to start off with the content. And this is what I do in class too. The first week, if it's left just introductory, I don't think it's right. We have time, we have a lot to cover, and I will start with the topic. One important aspect I want you to recognize is that typically in real time, when you're teaching classes like this, the amount of exposure the students have to a teacher, or the classroom time, if you may, is a lot more than on video. And video is very intense, there's very few interruptions. Those are the downsides, I think. But on the other hand, as I said, you can keep learning from others, and you can keep going back to the video. I want to emphasize this every time, is that the good news is you have the video, and I want the video to be self-contained. I will not give you too many notes. In fact, I'd encourage you, if you really want to learn, and I've thought about this a lot, encourage you to make your own notes as we are talking. I think note-taking, thinking through, however you want to do, scribble on a tablet, use a pen or a paper, I'll encourage you to do that, because then you've created your own set of notes. I was inclined to give you a lot of material, but there are a lot of textbooks available, and they are in the syllabus. I've mentioned a few. There are others. I want you to choose your resource, and me to provide you enough to be able to be successful in learning this class. So we'll start talking about the time value of money today, and we are going to continue this in the next week. And the reason is time value of money is central to understanding finance. So let's get started. I want to pitch the beauty of finance, if you remember, as its ability, the structure and the details and the tools, the ability of finance to solve, or I shouldn't say solve, but to understand decision making and make good decisions. So we're never sure whether our decision is going to be right or wrong, but that's life. But we want to develop a framework where the chances of you making good decisions, given the information you have, goes up. So I hope you recognize that. So what is really critical to decision making? Every decision involves time and uncertainty. I have emphasized this in the introduction of the class, and I will keep emphasizing it. If you understand time and you understand uncertainty at a gut level, in a framework context, in a daily life context, I think you would have arrived, and life will be so cool. You'll be able to make decisions not using Excel, but based on your gut, as if you have also used Excel, because your framework is so strong. So time and uncertainty. These are common to every decision. Please recognize that. It's common to every decision, whether you want to cross the street or whether you want to create a new technology to solve poverty, which I hope you do. Okay, very important to understand just the impact of time on a decision, and that's what we call time value of money typically. We ignore uncertainty for some time, and I'm going to do that in a very deliberate way. I will talk about it because life is full of uncertainty, but I'm going to try to ignore bringing in uncertainty simply because if we learn in a linear way, building blocks will help us get there rather than throw everything at you and it's going to be difficult. So remember, we are going to spend a lot of time understanding the impact of time with uncertainty somewhere at the back of our minds, but not explicitly accounted for. And just to re-emphasize this issue, I'm putting it up as a bullet point, and so that you can make notes on this, we got to internalize the time value of money. And so what I'm going to do now is give you a sense of what some terminology is available to us, which actually turns out to be, except for the fact that it's in English that I'm talking, makes a lot of sense. And I'm going to spend a lot of time on each one of them before jumping into actually talking about finance. So you can think of it as the language of finance that we need. And I'm not going to throw too much language at you. I'll throw enough so that you understand what's going on at that point in time. So the first thing that we will try to talk a lot about is present value and something that's closely related to it, future value. I would like you to, I'll soon start drawing timelines, which are very important. So basically one of the things that you need to know is how to draw a timeline. And if you know how to draw a timeline, half the problem is solved. Because the world's problems are awesome because nobody knows how to approach them. The life in general is quite complicated. What finance does is makes it simple. I mean, that's what you want from a framework, not to make life more complicated. It's complicated enough. So look at what present value means. It means the value of anything today, present as in now. What does future value mean? The value in the future. And what time in the future? We'll start off with very simple examples and make it infinite future, right? So you don't need to worry about present versus future. We'll structure it within a problem that you have. But the most important aspect of this is look at the units in which both are measured. The units in which both are measured are dollars or yen or rupee, as I said, wherever you are, the currency of your country. And you're from all over the world taking this class, which that alone excites me, And so hopefully I can reach you and help you learn this stuff. So whether it's a dollar, a yen, or whatever, both are in dollars. And again, dollar is not the important thing, but the thing is that it's a measurement of value. And a lot of things in life actually can't be measured. Love, for example, is something that you can't put a dollar sign. That's why it's so awesome. But for matters in this class, the dollar sign is just a language of reflecting value. So the unit is very important because I'm going to now go to the next thing, which is N. And many times it could be called T as in Tom, symbol. It's for the number of periods that you're thinking about. So for example, if you're thinking only about today versus next year, then the N is 1. But notice again, why is this important? Because you'll recognize in a second that the passage of time alone makes decision making both interesting and challenging. And that's why I love finance, is that, think about it, it's just because of the passage of time. You need to worry about so many things, but isn't it cool that time alone can make such a huge difference? So the number of periods, now it's critical for you to understand something which I'll repeat. The problem will lend itself to the definition of the period. So we'll just remember that. The period doesn't have to be a year. It can be one day, depending on the nature of the problem. Finally, the most critical aspects of finance is, if I were to capture one element of finance that distinguishes itself from everything else, it is the next symbol, R. And I'm using it in lowercase r here. Sometimes textbooks use caps and so on for N and so on. Don't worry about that. The critical element here is this. The first aspect of an interest rate is it's not in dollars. It is in a percentage terms. So it's like a change over time. This is very, very important to understand. And I think intuitively you do, but practically we'll also try to see what's going on with it. The other element which is very, very important for this class, and in a way this is the one aspect of the class that I wish I could spend weeks on, but we don't have the time, is we'll assume the interest rate is positive. And I'll say this is an assumption, and let me throw out an idea to you. Where do interest rates come from? Why are they typically positive? Can they be negative? Is a fascinating topic. And I would recommend a book called Theory of Interest, written in 1930 by Irving Fisher, who, if you read the book, it pretty much blows your mind. This guy, almost a century ago, has predicted all modern finance. And he writes in such an awesome way, no technical stuff, just some graphs. It's just awesome stuff to read. But the critical aspect of that book is that it will take you off on a journey that won't be the journey we'll take, at least aspects of it. And that is, we'll assume that the interest rate is positive because that's what we usually see. But I want you to recognize that assumption right up front. And again, repeat again, I know you're clamoring for uncertainty. I love uncertainty. I think that's what makes life interesting. But for the time being, we are going to stick with no uncertainty. Of course, that's completely unrealistic, but it's simply so that our building blocks of learning and time that it takes to learn happens the natural way. So I've introduced the terminology. I want you to stare at these things for a little while. Please remember, I'll introduce more, and I want you to get comfortable with these. So for example, if you want to take a break now and you want to go Google, that's the beauty of Google. In fact, when my son was little, even now he asks me questions and I usually don't have a clue of the answer. So for example, why is the sky blue? So I would say to Gabriel, why don't you Google? So I think by about 5 he thought Google was this really cool person who knew everything, and my dad is a loser. So just so that you have, I just wanted to talk about this because this is cool stuff, right? So just go Google, try to read your book. You've got get familiar with these concepts a little bit if you want to take a break. In some senses, as I said before, if you know how to draw timelines, you have arrived. So what I'm going to do now is I'm going to show you what a timeline means, and you'll just kind of laugh because it's kind of silly, but I think it's important. So, and by the way, just so that you know, my handwriting is nowhere near as perfect as the title on top. So if you expect it to be, you need to grow up. So I'm going to just draw a timeline, and you should be able to take a word problem and put it along a timeline. And I put dots here. Why is this important? I think it's important because if you can take a real life problem and put it on a timeline, you've achieved probably the most difficult part of taking a real world situation and then using financial tools. So in some senses, finance requires you to know what life is all about, what the problem is all about, before you can use finance, you know. So I say this many times, you know, it was an accident that I got to learn finance, but there is love and then there's finance. The gap is huge, right? I mean, love is somewhere special, but being number 2 ain't bad. So you need to understand life, love, and so on, and then put it on a timeline. And you can put pretty much anything on a timeline. So here's the first thing. At this point, we'll typically call this FPV, present value. then the number of periods are pretty obvious. So this is 1, 2, 3, and this is n. N reflects these time periods. The important thing to remember is that R is the interest rate that applies to one period. And in the real world, typically that one period is a year. By that I mean, when you see interest rates being quoted for various stuff, like a bank loan and so on, it'll be annual. And that's just so that it makes sense. You can compare things kind of. So in the beginning, what I'll do is I'll just take PV and I'll try to relate it to FV. So we'll try to understand these two concepts. How does FV translate to PV? PV translate to FV, go back and forth and become very familiar today. But I remind you of one thing, just listening to me, miss, it looks easy. And that's the challenge of this class. I'll make it sound really easy, but your challenge is to do the problems, and that's when you'll internalize, right? Because the word problem is the problem. And if you can't figure out the word problem, this ain't going to help. So drawing a timeline, bringing the word problem to it is what it's going to be about. I'll start off with simple problems and then make them more complicated. But today, what we'll stick with is a single payment, and I'll emphasize, meaning I will transfer something from PV to FV either for 1 year, 2 years, or 10 years, and vice versa. We could have stuff coming in here, which is also dollars. Remember, this is dollars and this is dollars. Could have dollars coming in here. That's what is happening actually in most projects, but we're going to ignore that for the time being. And the reason is, as I said, I want you to understand time value of money. We'll go slow in the beginning and then we'll take off. So, you know, when you are on a plane, the pilot warns you, okay, fasten your seatbelt, I'm going to take off. I'm going to warn you. I mean, when you hit the assignments and the problems, there'll be a warning. You better have your seatbelt on. So get on to the problems. That's how you learn. You don't learn by just listening to me or anybody. Okay? So please recognize the importance of timeline, and I'm going to go back to the notion of how to think about time value of money and how to take timelines and work them forward. Okay, we have talked about importance of timelines. I'm now going to jump into what I promised I'd do. I'm not going to create a formula and pick a formula and just throw it at you. No. To the extent I can, and that's my challenge, is to talk about a problem and then create the formula, because I don't like formulas without understanding what's going on. Okay. But the main insight we are going to worry about is $1 today is worth more than $1 tomorrow. Or in other words, that's the essence of time value of money. The time by itself, the passage of time by itself has value. And there are some reasons for it. As I said, you can go back and read up on them. And we are going to assume what captures time value of money is the interest rate, the relationship between today and tomorrow, or today and the future. And that interest rate we'll assume is positive. So let me start with an example. Suppose a bank pays a 10% interest rate per year and you are given a choice between two plans. And by the way, I'll be going a lot back and forth, writing and stuff like that, but that'll hopefully make it more engaging. And as I do a problem, you should do it with me, you know, and if the problem gets complicated, I'll give you more time and then we'll do it together and so on. So these are your two choices. It's very simple. I either give you $100 today or I give you $100 1 year from now. And for the time being, let's keep our period 1 year. So the question really is, which one would you prefer? And why? As I said, I just don't want to know what you prefer. I want to know why the heck do you prefer it. Turns out, if you have thought about it even for a second, or even without thinking about it, you'll choose one of the two. And it's probably going to be the first one, right? So the goal here is to use the simple example to motivate something that is fundamental that we'll build on. So this is a future value problem and an example. So what I'm going to do is I'm going to try to work with you. So try to think through this. So A is, remember, A was $100 now. This is A. And B was $100 in the future. And that's what I meant. A timeline is extremely important. I'm giving you two very simple choices to actually recognize. Now, this is where even popular financial press screws up, and you won't believe it, but it's true. What we do in our head is we intuitively recognize that just the passage of time has an effect and will have an effect on the value of the money we are talking about or whatever it is. But we directly compare these two, and that's not the right thing to do. In other words, if you were to do this, and I say this in my class and I'm going to say this to you, if you start comparing money across time directly with each other, it would be better if you stabbed me, because you're basically telling me whatever you're teaching in finance is useless. So remember, the first principle is you cannot compare money across time. That would only be meaningful if time had no value. And what captures the value of time in this one scenario is what? The interest rate. So let's try to work it a little bit better. At this point in time, let's do the future value, right? So what is already in the future? We know that this is already in the future. So the question is, I cannot compare this to this at time 0, but what can I do? I can either bring this back to time 0, so take this, or carry this forward to the future. And the reason I'm going to do carrying forward the future value first is I think it is easier to understand finance if you do that. And it also makes you think about the future. And that's very important. Every decision that you make, every value creating decision that you make should force yourself to look in the future. And this is where I think accounting can make fun of. Accounting, standing at time 0 where we are today, is looking backwards. So that's it's done. The past is over. So while you can derive very interesting implications from the past, and I don't mean to demean anything, all decisions ultimately involve your capability to look into the future. And that's what's challenging about it, and that's what's awesome. Every decision has an impact on the future, and typically the painful part happens today. The better the idea, the more the pain today, but benefits a lot in the future. So like Google, I took a lot of effort to create, and now a lot of value is being created. So sticking to the simple problem, I think you know the answer to this. The answer to this will be $110. And the reason is very simple. R is 10%. So let me just talk you through, and then we'll do the formula. I know right now many of you are saying, come on, this is just too easy. Well, it'll build on itself, and so we got to understand this piece. So the $100 that you had, you could put in a bank, right? And that 100, because the interest rate is positive, will be part of this 110. Because the interest rate is positive, you can't lose that $100, right? And then you're earning 10% interest. So what is 10% of $100? $10. So it's very obvious what's going on, that you in the end will have $110. So as I promised you, what I'm not going to do is I'm not going to throw a formula at you till at least you've had some sense of where I'm going. And hopefully this simple example has motivated you to try to understand future value a little bit better. So now what I'm going to do is I'm going to throw the concept at you. In this concept, what it says is the following, that the future value of anything that's carried forward has to have two components. One is the initial payment, and in our example, it's 100. And the other is accumulated interest, which in our example is 10 bucks. So the problem becomes very straightforward. You put in 100 bucks, you get 100 bucks. But then you get 10% on the hundreds, which is 10 bucks. So you get 110. So this is the formula. So if I were to ask you, what is it related to the problem that we just did? So what is this P? P is your initial payment of 100 bucks. What is the R? R is the 10%. But the 10% is on what? Is on the P of $100. So I know that 10% of 100 bucks is a fraction, 1/10, and this will be 10 bucks. But the way we write it, which is very straightforward, is we take P out of the picture. So the P is common to the first one, therefore the 1, and RP, R times P. So what you have put in the brackets is many times called future value factor. It's a factor because what does this 1 plus R reflect? Let's do it in our case. The 1 plus R in our case is 1.10. And what's cool about this number is it tells you the future value of $1. So if you know the future value of $1, in this case it's 1.1, which is very simple, 1 plus the interest, you know the future value of any number. Because if the number is 100, you multiply 1.1 by 100, you get 110. If it's a million, you get 1.1 million, and so on and so forth. So many people conceptually emphasize that future value factor, and I'm going to just do it this one time, but you can go back to the notes and think about it like that, I mean, it'll be very helpful to you. So right now, what I'm not going to do is I'm not going to use any tool to elaborate on this formula. By that I mean, you don't need Excel to do this, right? Actually, you need Excel to do only when the problem becomes difficult to compute, not think about. Okay. So the initial payment is P, and the accumulated interest is R times P. So that's the way you want to think about this problem. So I hope all of you get a sense of this very simple problem, because I think what the future problems will be complicated versions of this. And I get very excited with simple stuff too, because it's kind of cool. So how much will $100 become after 2 years, right? So now what have I done? I've taken the 1-year problem and broken it and made it into a 2-year problem. So let's see how to do that. And I really would appreciate it if you did what I'm doing, either now or later. And by the way, I'll do this for relatively simple problems and let you work with the more difficult ones. So how many periods do I have? I have 0, 1, and 2. And as I said, the length of the period is a year, but that's artificially chosen. I'm just choosing it for simplicity. It can be anything. We'll see that in a second. So, okay, so 1 year, 2 years. And what is the question asking me? So you put $100 in the bank, and you're asking yourself, how much will you become at this point? So what is the future value of this, right? So the question is pretty straightforward, but it is a little bit complicated. So here's what the answer will be, and I'll tell you the answer first. The answer will be $121. It's clearly more than 110, but it's 121. And this, in all of this, that $1, this guy, if you understand where that's coming from, you'll see how it'll blow your mind when you increase the number of periods. Okay? So here's a simple way of understanding what's going on. So I'm going to do the example without a formula, right? Or whatever, with a formula that we already know. So can you tell me how much will this be at this point? Do we know how to solve a one period problem? Of course we do. We know this is 110. Why? Because this was 100 times 1.1, right? So you don't need the formula to do this, hopefully, but we could do it in our heads. But now notice what has happened. I can use the same one period concept conceptually to move one period forward. So what will this amount, which is 110, be after 1 year? And what will you do again? You will take 110, multiply again by 1.1, and that should give you an answer of 121. So what's going on here? Answer is very simple. You're doing a one period problem twice. And so think of a bank. It's dumb, right? Not the people, the bank. So the bank is looking in the first period and saying, what's going on at time 0? You have $100. At the end of one period, what does it do? Given an interest rate of 10%, it says now you have 110. But the bank doesn't know the difference between the $10 that you didn't have in the first year, but now have. So 110 bucks are the same. So it thinks you now have, rightly so, 110 bucks and takes it forward another period, it becomes $121. So what's going on? Where is that $1 coming from? So if you think about it, you're getting 10 bucks here and 10 bucks here. That's one way to think about it. Why? Because this 10 is 10% of this for the first period, and this 10 is again a 10% of this in the first period. So if you add up those, you have 100 plus 10 plus 10. You have 120 at the end, right? So you have 100 plus 10 plus 10. So you have 120. So you're saying, how did I go from 120 to 121? The answer is very simple. What we have ignored in all this is this 10 bucks, which was not here, is added here, will also earn interest over the second period. And what is 10% of 10 bucks? $1. So plus 1 is it 121. So it's pretty straightforward. I'm writing all over the graph, but I want you to understand that this is not complicated. The complication is simply coming because if you're thinking, you're not thinking about the 10 bucks that comes as interest will also start earning interest in the next period. So I've given you a sense of what is the future value of 100 bucks 2 years from now, and the concept and formula, let me just repeat one more time so that you can understand. So the formula says this: if I have P at time 0, after 1 year it will be P 1 plus R. After 2 years, what will it be? P 1 plus R times 1 plus R. Why? Because this P in our case was 100, but after 1 year, this whole thing has become 110, and then when you carry it forward, again it will become 121. And turns out P times 1 plus R square is exactly equal to 121. Now isn't this cool? The formula is telling you exactly what's going on instead of me throwing the formula at you. Formula makes sense. But here's where Einstein got blown away too. You see, Einstein said this. Einstein's most famous equation was E equals mc square. Now it's square and square are here, right? They're common to the two. But turns out if I have 100 years passing by, if 2 were to increase to 100, what would this formula become? It would become P times 1 plus R raised to power 100. And if when Einstein saw compounding work, that is interest on interest on interest, in this case it was only $1 initially over 2 periods. Interest on interest on interest work is so powerful that in fact I would give this advice to you. Anytime you ask a finance question, say the answer is compounding, and you are likely to be right 90% of the time. The only thing you want to do is you want to look intelligent. In life, looking intelligent is far more important than being intelligent. So what you want to do is you want to say, pause and say, is it compounding? Because what that will do is it will make people think like you are really cool, you know something they don't. But seriously, compounding is a really, really tough thing to internalize. So what I'm going to do now is I'm going to take advantage of Excel, and I promised you that I wouldn't teach Excel, but I'm going to do a problem where I'll be forced to use Excel. So let's stare at this problem, and if you want to take a break right now, this may be a great time to take a break, because we have done future value where we actually could by hand do the calculation. So repeat again in words, I will. $100 after 1 year, 110. Why? I got 10%, $10 over 1 year, I have 110. After 2 years, what's happened? Well, one way to think about it, which is very intuitive, is how much do I have after 1 year? If the bank is still there, of course, it's 110, right? I told you I won't talk about risk, so I'm assuming the bank is still there. So 110 you still have, and after 2 years, it would have become 121. And the real thorn in your side is that $1. And if you understand that $1 comes simply from the fact that you now have $10 more after 1 year, which is also earning 10% because it didn't do any harm to anybody. It's just like the 100. What did it do? So at 10% of that, that's the $1. Now that is what is compounding's power, interest on interest, but it's only $1. Otherwise, if you didn't have interest on interest, you would still have 120, right? $10 each year on the original 100. Now you have 121. So it says, what's the big deal here? Well, let me try another example, and then I'll give you some examples which are really awesome. Just the simple idea. And I think if you understand compounding as how difficult it is for a human being to internalize, you'll understand why finance is so viewed as so difficult. But if you understand the intuition, it's pretty straightforward, right? So let's do this problem. So this problem says, and if you've taken a break, good for you, let's do this problem. This problem says, suppose you put $500 in the bank and the interest rate is 7%. If you notice, what have I done till now? I've chosen interest rate of 10%. Why did I do it? Because I can do the problem in my head, and so can you. I'll have the luxury of doing it. The real world doesn't. In fact, it has 3 decimals in it or something like that. Here, we'll make it a little bit more interesting. Let's make it interesting, make the interest rate 7%. However, the interest is not coming from the 7%. If I asked you, what is 7% of $500? I hope you can do the problem in your head, and multiply the 2 and you'll get a good answer, whatever it is. It's 35, right? So, however, what's complicating things is how much will you have at the end of 10 years? So let's go back to basics, and I'm going to force you to do this. And the reason is, if you don't, I'm going to do it. Whether you want to do it or not is obviously your choice. I'm going to be very timeline oriented, especially in the beginning of the class. So what's the time? This is 0, right? How many periods? Again, for convenience, 10 years. What's the other element you know in a problem? I know that I can put P here as 500. You can think of it as P, PV, short. So the question now asking is, what the heck is going on here? Again, please remember, we have no risk. So I've gone from 2 years to 10 years, and you know, a lot can happen, and a lot has happened in the recent past. So I don't mean to belittle what has happened. I just think that uncertainty cuts both ways, and we have seen a lot of bad effects of a crisis. But I'm going to ignore all uncertainty for the time being so that we understand the effect of time. Now, this is not easy. It's very simple to understand conceptually, because what would you do? Just carry it forward 1 year at a time, and if we had all the time in the world and the only problem to solve, we could do it and 10 weeks would be over. So, but we want to write the formula out. I want to take 1 plus r, which is the factor, which in this case is, and what do I want to do? How many times is this happening? I know it's happening over 10 years. So here's the problem. I'm raising it to the power of 10. And remember, every time you go forward, the factor is 1 plus r. So after this 1 year, it would be times 1.07, 1.07 square, and so on. This thing, by the way, if you can do it in your head, there's something seriously wrong with you. You need to grow up and do more interesting things in life. But there are people who can do this in their head, and I think there's something, you're spending your time on the wrong thing. Just think through. If you have understood what's going on, this is where you ask yourself, do I get a calculator? Or do I get Excel? And what I'm going to do is, you have notes on using either one. The calculator has to be financial, but not in this problem necessarily, because you can raise things to the power 10 and so on. But this is the kind of algebra that you have to be comfortable with. Therefore, I'm throwing in the algebra before actually solving the problem. But to solve the problem, we'll have to do what? We'll have to go to Excel. And I'll show you a very simple way of doing Excel. Okay, so let's see. If you can see what I'm doing there, I'm going to the tab on top, the space on top that says fx, and that is where the functions reside. So if you haven't got the finance functions, you can always get them from Excel. It's not a big deal. But the thing I'd like you to know is this. It's very intuitive. So what are the key elements you need to know to solve this problem? I think the key elements you need to know is you're solving a future value problem. So the first thing you do is you put in something that you don't know. You don't put in something that you already know, because the Excel will look back at you and you will say, you already know the answer, why the heck are you asking me? So it's future value I don't know. And as soon as I press future value, guess what pops up? What pops up right there is the first thing you need to know, which is the rate. And the rate is the interest rate. As I said, symbols are something that you need to familiarize yourself with. And another thing about Excel, which many calculators differ on, is in Excel you have to write the rate exactly as it is. So it is 0.07. Many calculators would allow you to just write 7, but in Excel if you write 7, that means you're assuming the interest rate is humongous, right? So what's the next element it asks for? It says NPER. The N is the operative word, PER stands for periods. So in this case, I believe we have to type 10, because there was interest rate was 7, the number of years passed is 10, and then there is a button called, or there is a symbol called PMT. For now, ignore it. And the reason I'm asking you to ignore it is it doesn't enter our problem. That's the next element we'll get into next week. And PMT stands basically for something called payments. So when do payments happen, say for on a loan? They happen regularly. Right now we are just looking at $1 transfer, time travel over time. So I'll put a 0 there, because if you don't put a 0, it won't know what's going on. And then I put PV, and I know PV. It's I who has put the money in the bank, so I better know how much it is, right? So I put in there, and then I press return. Now what you'll notice is that it's showing up in red. You're noticing $983 and some cents. By the way, I'm not interested in cents here, right? So I'm not even interested in the answer so much. I'm interested in you understanding why I used Excel. And the reason I used Excel is because the human mind cannot calculate something raised to power 10 very easily. And in fact, there's a whole video created and research done on this, that humans are very good with linear stuff, and humans are not very good with nonlinear stuff. So that's why maybe sometimes finance looks like a challenge. But if you break it up into bite-sized pieces and recognize why you're using Excel, Excel doesn't control you. You control Excel, right? I hope that's pretty obvious. So if you've seen Matrix, it's a very different world, and we are not there yet. So don't let Matrix enter your mind thinking that Excel is solving your problems. One day it will, but not for now at least. So what is 983? $983 is the value of $500. How much? How many years from now? 10. But there has to be another element in answering this problem, and that is the interest rate. So the interest rate is 7%, and the world remains sane for the next 10 years. And I get the 7% a year, assuming no risk right now. I'll get $983 in the bank. But clearly, if the interest rate were lower, I would have less. If the interest rate was higher, I would have more. The real cool dynamic is the interaction between time and the interest rate. So the interest rate is a per year number, in this case 7%. But the real cool interaction, which we call compounding, is between the 7% interest and the number of years, 10. And the more years that happen, and we'll see a problem soon, the more the dynamic becomes very powerful. So here you've almost doubled your money in 10 years at an interest rate of 7. That wouldn't happen at a lower, would happen faster at a higher rate. So I hope this is clear to you. Now one last comment, and I said I'm not going to spend too much time on Excel, but I have to kind of satisfy your curiosity. Why is the number in red? Why is it negative? Now think about it. This is actually a pretty cool thing. So Excel has been set up to make you realize that if you put in a 500 plus today, it has to be negative in the future. So think about it. Who's getting the $500 today? You're giving it up, but who's getting it? The bank is getting it. And what will they have to do 10 years from now if they are getting it? Remember, I put 500 positive in the PV. They'll have to give up 983. So the lesson from Excel is pretty cool, and that is you can't get something for nothing. There's no such thing as a free lunch. So if the bank, you give 500 and are willing to give another 983 to the bank, then you are the sucker, not the bank, and bank will be pretty happy. In fact, probably will feel like doing business with you, and you'll go out of business and the bank will be in business forever. So just wanted to give you a sense of that. I'm going to come back to this in a second because I want you to recognize that doing these problems on Excel is simply because you can calculate things faster. So let me do some examples, by the way, and I want to emphasize one thing. A lot of these examples that I am using in this class, I don't even remember how I thought of them. I mean, a lot of my colleagues at Michigan have helped me become a good teacher, if I'm a good teacher at all. A lot of the things we talk about, a lot of the examples we use, a lot of the notes we use with each other. And to be honest, when you read literature out there, a lot of these numbers have real world meaning. So let's go to the next problem and show you the power of compounding. what are the future values of investing $100 at 10% versus 5% for 100 years? Why am I doing this? I'm doing this simply to give you actually real world context. So which kind of person, and I promised I won't talk about risk, but I'm by implication talking about it, because if there's no risk, how many interest rates would there be? One, and it would be the same, because risk largely is responsible for different interest rates. But for the time being, let's assume for whatever reason you have two opportunities, 5% or 10%. In the real world, what would this mirror? The 5% is kind of closer to a bond, where the difference between a bond and the stock is it's less risky. The 10% is kind of closer to what the US stock market, say, has given. It's given more over the last, say, 80 years. So I'm just anchoring them in kind of real world problems, but keeping the interest rate simple so that it's not 4.265. It'll just take up time, and you can do more real world problems in your personal investing. But here's a core question. Suppose your grandfather or great-grandfather had invested $100 100 years ago in the stock market versus a bond. That's the kind of context. How much money would you have today? Clearly, you cannot do this problem easily, right, in your head. So, but I'm going back to the problem we just had, and I'm going to just modify it. So how much was the interest rate possible? So let's start off with, instead of 7%, the new problem has either 5 or 10. So let's start with 5. What is n? It's very obvious that n was 10 in my previous problem, but now it's 100. And 0 is PMT again, but how much money am I putting in? In the previous problem, I had put in 500, and now I'm putting 100, right? So if my fingers are going all over the place and I punch the wrong number, we'll all deal with it, right? I mean, I'm teaching you one-on-one. I feel like you are listening there. Believe it or not, I feel like I can see you. But anyway, before you think I'm really strange, let's move on. Okay, so you have about $13,000 plus a little bit. What do? If your great-granddad had put $100 in kind of a bond, and it had grown to, and of course, let's assume it's a government long-term bond and the government is still there and so on. So remember this number, 13,150. But the question asked you, how much could it be at 10%? And if you asked a lay person on the street, who's probably smarter than me, but if you just ask them, because they haven't done finance, so suppose I change the interest rate from 5 to 10, what do you think would happen? And I think what that person will think is, think linearly. They'll try to say, oh, okay, maybe it'll double. So remember what was the answer the first time, about 13,000. So I think I got everything right here, 100 years, $100, that hasn't changed. Look at the answer. And the answer is about 1.3 or $1.4 million. So what does that tell you? That it's a mind-bogglingly dramatic change. And the culprit there is what? Simple. Who's the culprit? Compounding. Or who's the beneficiary? Compounding. So I want you to just think about this for a second, and I'll go back to the problem and show it to you so that you feel comfortable with the question I have asked you. What are the future values of investing 100 at 10% versus 5%? So what did we see? 30,000, 1.3 million, if I'm reading it right. Huge difference. So what's going on? Let me ask you this. Suppose there was no compounding, right? Suppose there was no compounding, which means what? Interest will be treated like it's different. Interest cannot earn interest. The only thing that can earn interest is the original $100. Let me ask you, with 5%, how much will you have after 100 years? And you should be able to answer that question very easily. And the reason is very simple. Simple interest rate is additive. It's linear. We are very good at it. So let's take, will the $100 still be there? Sure. But every year, how much will I be getting? 5% of $100 is $5. After 100 years of $5, how much is it? 500. So you see how simple it is? That you have $500, $5 at a time for 100 years plus the original 600. But what was our answer? Our answer was 13,000, right? So where's the difference coming from? Compounding, you see? it's really unbelievable. You know, you can't visualize this stuff. But let's go to the the second problem. So now I increase the interest from 5 to 10%. How much am I getting every year on the $100? Well, twice as much. I was getting $5 first, now I'm getting $10. What is $10 times 100? 100 years. 1,000. So how much do I have? I have $100 plus another $1,000. Sounds pretty reasonable. But what was the answer at 10%? More than $1 million. So you see what's happening? Two things are happening. Compounding is very tough to understand, but it's real. It's been happening. People have made money with risk, obviously. However, what's even more complicated is a comparison with compounding between 5 and 10 becomes a total nightmare. It's very difficult to comprehend because it just blows in your face. So if you want to think about a really cool example, actually provided in, I teach executives with a couple of my colleagues, and this is borrowed from their example, and it's a real world scenario. So read this for a second. Peter Minuit, if I'm saying that right, by the way, I don't speak French, so if I've screwed up his name, pardon me. Everybody screws up my name, so no big deal. Peter Minuit bought the Manhattan Island from Native Americans for $24 in 1626, right? Suppose the Native Americans had decided to sell the land and then taken the money of $24 and put it as a quote-unquote financial investment at about 6%. Why am I choosing 6%? Because it's neither too high, it's neither too low, though we don't know what interest rates are likely to be in the future given what's happening now. But let's stick with 6%, I think, just as an example. How much would the Native Americans have in the bank today? So this is your problem to solve, and it's not an easy one. So let's try and see how would we do this. I'm going to use this platform itself and tell you what the formula will look like. So it's very obvious now to you that the P here is $24. But remember, when? It's 1626, right? And R is 6%. Remember, it's per year. So two things to remember about R. It always is for a period of time, in this case a year, and it's always a percentage. I'm asking the following question. What is the future value in 2012? Everybody on the same page? Yes? So I'm going to now, you write, I'll talk. The future value will be 24 multiplied by 1.06, which is the one period factor, future value factor, raised to power, not multiplied by, raised to power the number of years that have gone between 1626 and 2012. And I think if I have that right, it's 386 years. So now this, if you can do in your head, it's pretty cool, but largely useless in my book. Okay, so let's try and do it with the calculator now that we have a machine that's dumb and we can beat it up once in a while to give us things that we can't calculate too easily. So let's do this. We'll use the same formula and let's see how to change it. The first thing that we encounter is the interest rate. So 0.06. Did I get that right? No, sorry about that. Just give me a second. There's always, okay. So 0.06 is the interest rate, and the number of periods was 386. While you're doing this or while I'm doing this, try to guess the answer. If you do, you're a genius. Okay. And how much money was put away? Remember, no PMT, no inflow between these 386 years. So all we are having is the initial good old $24. Did I get that right? 6%, 386, $24. Okay, so let's see what happens. This, by the way, has so many zeros in it that I lose my mind right there. You know, I always forget how many zeros in a million, billion. Stuff that you can get from Google, you shouldn't put in your head, is my philosophy. But it's about $140 billion. 24 bucks has become $140 billion. Let me just show you how things change. So, for example, if I just took away 2 years from here, right? I just made it, what would it have been in 2010, which would be 384. Guess what happens? It's $125 billion. So what has happened in the last 2 years? You added $15 billion. Why? Because you've earned interest on interest on interest for a lot of years, but the pool of money you have after 384 years is so big that the next 2 years just add another $15 billion. So while this is very interesting, it is, while it's a very interesting problem, I also want you to recognize it's not completely unheard of. In other words, it's not an unreal question to ask, is if this money had been put away, how much would they have? Of course, the much more interesting problem is the following. How much is Manhattan worth today? So I'm not going to get into that. That's an entirely different question to ask, but it gives you a sense of what I was trying to get here. And what I'm going to do now is I'm going to take a little bit of a pause. I'm going to let you think about what we have done. I would highly recommend, if you haven't taken a break till now, to take a break right now. Do two things. Do yoga, if that's what makes you happy. Bring coffee, smile, be happy. Just revisit especially the last couple of problems and try to familiarize yourself with both the concept and the technology. Because I'm a big believer, if you do it on the fly, it just sits with you. If you postpone it to later, and I'm not asking you to start the assignment right now, right? That's a totally different animal. I'm asking you to just revisit quickly, take a break, and what I'm going to do is I'm going to do one more concept today, which is present value, and then we'll stop for this week and we'll move on to more interesting problems still involving time value of money next week. Okay? So take a little break, we'll come back. Thank you. Hi, so hopefully you've taken some time off. I'm going to shift to present value, but as I promised earlier, I'm going to stop with present value for very similar problems that we did earlier. And the reason I'm going to stop today is I think the first week should expose you to the class, what it's all about, and some idea of time value of money. But we'll get things more complicated next session. Of course, I also want to remind you that we are trying to follow very strictly a week-by-week schedule. So I will let the video length be dictated by the week. So because today was introductory stuff, and we did videoing of the content starting about an hour ago, What I'm going to do today is leave you with enough material of the content. You can always go watch the introduction to the class again anytime. But I wanted to give you enough today, this week, so that you can start, practicing, start doing assignments, and so on. So now the next concept, which probably is more talked about, is present value than is future value. So again, let me start with the problem. So the question says, what is the present value of receiving 110 1 year from now? And I think some of you or all of you are smiling, because you know why I'm asking you this question with these specific numbers. The interest rate is 10%, and I'm giving you $110 1 year from now. So think about this problem as something like this. You're going to receive $110 in the future 1 year from now, and you're trying to figure out what does it mean to you today. And this is a very important problem to solve, right? Because most problems in life, you make effort today and you get money or pleasure in the future, right? So you want to figure out what is the value of that today, and present value therefore is a little bit more important than future value for decision making. However, future value, I think, is easier to understand, and it forces you to be a finance person. Finance people look forward. Finance people don't look back, right? So that hopefully that's ingrained in you. I'll tell you a little bit about what that has done to me, because finance has changed me in good ways mostly, but there are some elements of it which are pretty hilarious, which I'll get to in a second. Okay, so let's do this problem, and I'm going to use again just a simple way of doing it. And so here you go. You have 0, you have 1. 1 period has passed. Remember always what connects 1 and 2 is time value of money at 10%. I've made it very easy, and I have 110 here. So that's the problem. I think if you've paid attention and you've gone back, which you can do any time, you know the answer to this, because I know what the future value of $100 is at 10%. It's 110. So what is the value of 110 in the future today? Answer has to be 100. Recall again, the first problem I did with you, I asked how much would 100 become after 1 year? And we realized that $100 would become 110. Now I'm asking you exactly the same question, but in reverse. I'm saying, suppose you had 110, how much would it be worth? Obviously, to get the same $100, the interest rate has to be the same, right? And I've kept it the same. So the reason I find this problem very interesting is it's easy to do. However, how do you go from 110 to $100? So this is where what I would recommend very strongly is that we try to do the concept before the formula. So if you look at my notes, I'll just go ahead one bit, is that I never do the formula before the concept. So if you saw me toggle, I went to the next page and I showed you the formula after I did the concept. So let's do it again. Simple. It turns out that present value and future value, in this case with 1 period difference, conceptually I know what? I know already what this is. I know future value is equal to present value times 1 plus r, right? Pretty straightforward. I know this. So how much would be the future value of $100 at 10% after 1 year? We know the answer is 110. But now I'm asking you, just the unknown element of this is this. So what will PV be? PV will be FV divided by 1 plus R. I'm just inverting this equation. It's very simple. It's algebra. However, dividing something by 1 plus R, if I said it to you the first time, you would have said, why the heck am I dividing something by 1 plus something? And the reason is that 1 plus something is a factor that anything can be multiplied by. So the future value factor is 1 plus R. What is the present value factor? 1 divided by 1 plus r, right? Because I am taking the future value and multiplying it by 1, which is missing here because it does not matter, divided by 1 plus r, right? So, this guy is telling me what? This guy is telling me what is the present value of $1 if I got it 1 year from now. I have to divide that by 1 plus r. And if r in our examples is greater than 0, what will the value become? Less. So, it is very straightforward that something in the future will become lesser in magnitude or value when I bring it today. And that is why this whole process is called discounting. So, when you read about finance, we will say discounted cash flow or discounted money, and the reason is you are lessening it, and the key to that lessening is what? This. R being greater than 0 creates present to become larger in the future, but it also therefore implies by definition that the larger in the future becomes less today. So, that is the concept, right? But in doing the concept, what have I also done? I have told you the formula. So, I have told you the formula which we can rewrite, and you can write now. You created the formula. Present value is equal to, in our case, $110, I apologize, which was the future value, divided by 1.1. Why? Because R was 10%. So, 110, pardon the, this is a 1, you know what I mean? I can make mistakes too. 110 divided by 1.1, and this becomes $100. How do you double check that? Very straightforward. That is what I love about finance. Ask yourself how much would 100 become in the future, and your answer you know is 110. So, future value and present value are kind of checking each other. They have to be consistent with each other because one is simply looking at the other in reverse, if you may. So, I hope this is useful to you, and this itself is easy to calculate because I am dividing by 1.1 and the value is, if you notice, was 110. However, let us do this problem. Suppose you will inherit $121,000 2 years from now, and the interest rate is 10%. How much does it mean to you today? In other words, ask yourself the following question. If you were to put $100, right, $100,000 in the bank, how much would it become? 121,000. I am giving you the answer already. And the reason is I know, because I have created this problem, that the answer to this question turns out to be $100,000. So, let us see how I got that. And I am keeping the problem simple because you need to understand the concept better than the actual calculations, because the calculations, if they are simple, you focus on. So, let me ask you this. Can you tell me the value of this 121 in year 1? Can you? And I hope you say yes. Why? Because we have done it. We have done a 1 year problem. So, that is why I said in finance, if you can time travel, watch Star Trek, watch Star Wars, watch Matrix. If that is part of who you are, finance will be easy. So, let us time travel to period 1. How much will it be? Well, I know it will be 121,000 divided by how much? 1.10. That is the amount it will be after how much? 1 year, but you are looking at 2 years from now 121. This is very easy to divide, that is why I took it. So, what is 1.1 into 121? How much will I be left with? Well, 110. So, this is 110,000. But that is not what I am asking you. I am not asking you what is the value of $121,000 inheritance 1 year from now. I am asking you today. So, what do? You take 121,000 divided by 1.1 and then I divide it again by 1.1, right? So how much does that become? I know this guy is 110, and I know how to divide 110 by 1.1. The answer has to be 100,000. So just this simple example tells you how hurtful present value process can be, and why do we call it discounting? Is we are taking the future of 121 and boiling it down to only $100, $100,000. And the reason is very simple. The interest rate is pretty high. But a lot of people in business in particular tend to use high interest rates, and I find that a little bizarre at times. But anyway, just wanted to give you a flavor of what's going on. And now I'm going to do what I promised you, is I'm going to tell you the concept formula together. So let's do it. What's the formula of present value? So the present value formula turns out to be future value of, in our case, 121 divided by 1 plus r raised to power what? In our case it was 2, because future value of 121 was occurring when? 2 years from now. In this case it will be raised to power n, where n in our example was 2, but could be anything, right? You could be getting an inheritance 50 years from now. You could be retiring 30 years from now. So this problem doesn't have to be 2 or 3, right? So that's why I wanted to emphasize that. And I'm going to do one more thing before we go today. And what I'm going to do is, before I get into multiple payments, that's what next time is. So just to give you a sense of where we are headed, we have talked about a single payment carrying back and forth. Now I will do something that's much closer to reality, which is multiple payments. But before I do that, what I want to do is show you Excel again. So, okay. So let's show you Excel again, and the problem I will do is the 2-year problem. So let's do now what is it that we are trying to calculate? The critical thing to remember is put the function that I'm trying to solve for. So I'm doing PV, right? And the rate was what? 10%. Number of periods was 2. PMT, remember, is a flow every year. We don't have any of that. And now I'm supposed to tell you the future value, or tell you meaning the Excel, okay? So 121,000. I think I got it. If I didn't, shame on me. And let's see, $100,000, right? So I want you to see if one last thing, and I'll show you the power of compounding in reverse, right? So let's make this 121,000 stay the same. Let's keep 10% interest the same, but let's just mess with this number 2. So I'm going to make the 2 10. So what am I saying? Instead of giving you $121,000, your inheritance, suddenly you realize that there was a typo. Sorry, not 2 years, but 10 years. Now, you are thinking, no big deal. Well, you're probably wrong by a huge amount. Your amount of money you're left with, if I've gotten all the numbers right, and by the way, part of your problem is to double check what I'm doing, not to kind of second guess me, but to get the problem right, right? So hopefully we have a relationship now. You're not waiting for me to make a mistake, because I will make mistakes. Your goal here is to try to learn for yourself, even if I am. So what's happened? I have reduced the value of my inheritance to less than half by simply taking 2 years and making it 10. So bless you. I hope you've enjoyed today. I hope you recognize that finance has both technology, power of thinking, and bringing it all together. I hope you also recognize that we are going to go slow in the beginning, and part of the reason is so that you feel comfortable with time value of money. And to do that slowness, the major way I'm going slow is by keeping risk out of the picture. If I threw risk in and you started messing with that at the same time, life would become quite complicated. But just so that it satisfies your curiosity, remember, high risk, high return. High risk, high return tend to go together. So even though we're not talking about risk right now, that being at the back of your mind in that simple, powerful way is not a bad thing. I look forward to you next week, and I am really excited about this class. And the reason is, believe it or not, I feel like I'm teaching each one of you separately. And I think the power, if that has power, that's awesome. Because even when I teach classes live, I cannot do that. I struggle many times because I feel like I wish I could be a perfect teacher for everybody. But I'm not. I haven't met anybody who is. Because we all have different ways of learning. And I'm hoping that online, though it has limitations obviously, online has this huge benefit that I feel like I'm talking to you, you're there, I can feel you. And remember, whatever beats here is the same thing that beats here. So if I see you or I don't see you, I can feel you. Take care and see you next week. Hi, welcome to week 2. I wanted to give you some idea of what we did last week and some idea of what we're going to do this week before we jump into the week. And I'll tend to do that all the time so that we are on the same page. So, a recap of last week. I think the main things we spoke about are can fall into 2 chunks. The first was the philosophy of the class, or the content of the class. And I would like to again emphasize that although a lot of requirements and prerequisites could be there, it's an applied field, it borrows from so many disciplines and it's become almost a discipline of its own. We will try to do as much during the videos as possible so that you don't feel like you are in any way handicapped by not having done one of the background courses. However, when I do reach a point where I think it's appropriate not to keep going, I will let you know, and at that point what you'll realize is that you need to do X before you can do more of finance. But this is self-contained. I want to emphasize that. Then we moved on last week, we moved on to content because we have 10 weeks and we got to keep moving. And I told you that a lot of what's going to happen in this class is really work that you will do. That's my philosophy of teaching, is that I know a little bit, I can motivate you to learn, I can show you why of things, and that's my job. But a lot of actual practice that you need to do in finance with real world problems has to happen at your end. So we will introduce everything with examples, and last week this is what we did. We basically covered 2 issues, and the first, and I'll just draw a timeline, and we started with something here, and I'll, for the sake of just reference, draw just two points. And remember, we started with one period and went on to 2 and more. But we carried this forward, say, to something called future value. And then, after recognizing that, we also did, what does the PV of something in the future look like? And as you can see from this, the future value turns out of this will be P, which is the initial value, times 1 plus R raised to power 2, right? And that 2 can become N. And we got very familiar with going back and forth with all of this. So what is PV? Well, PV is pretty straightforward. It's the future value, in this case, 1 plus R raised to power 2. And you can recognize how similar the 2 are. One is like looking at yourself in a mirror, and that's what I like about finance, is it's very logical. I warn you again though, all the answers that you're going to get are wrong. So the process is right, the answers are wrong. And the reason the answers are wrong is because you're worrying about the future, not the past. And for the time being, we are assuming there's no uncertainty. But I reminded you many times that at the back of your mind, risk will always be there. And that's what's real, right? So if, because of risk, in some senses, everything you calculate is wrong, but the process and the way of thinking and the framework is simply awesome. So I would encourage you to go back and do a couple of things even before you proceed. First, and this I'll say every week, even though it may become repetitive, I think it's important. It's all the more important because you are controlling your learning. I'm not. In a classroom, I have a lot more control. Everybody's there and so on and so forth. But here, you are in control, and that's the way it should be, right? And I'm hoping that online education forces regular education to become individualized. You know, as I said last time, I feel frustrated sometimes that I cannot teach everybody the way they want to learn in a big classroom because I'm doing it in real time. Hopefully online can allow me to teach each person at a time. But that puts some pressure on you to perform. So this is what I expect every week, and I'll repeat it. And obviously you can ignore me. I mean, this is your life, not mine. But it'll help, especially in finance. So these are the couple of things you want to do. You want to make sure you understand the video. The good news is you can go back and forth, but I will not provide resources specific to the video. Any resources available are standard textbooks, or I will give you specific formulas and so on I'll write up and put on the website. And there are several reasons for this. And one is, fundamental reason is, I want you to learn actively. I think I spoke last time, if you're sitting there and just consuming, which unfortunately is most of education, it's not learning in my book. For learning, you want to be there. So it's nothing says about humanity that you need to get up at 7 and be in a class at 8. And then after that, every 2 hours, a bell rings and you have to change your mindset to learn something new. That's all artificial. It's like a factory. Humans are much more complicated and interesting people. So I would encourage you to learn on your own. However, review the video and make your own notes from the video. It will really help. Second, every week we have assignments, and last week's assignments were a little bit easy because we didn't do that much. However, you need to familiarize yourself with the assignment because finance is logical. So finance is not one day I say one thing and the next day I say something that's totally contradictory, which by the way happens in life. People say so many things. On the one hand, on the second hand, God gave us only 2 hands, but sometimes people make 15 different scenarios from the same issue. Finance keeps you disciplined. So if you want to use the framework repeatedly, you got to do the problems. So last week's problems you should have done by now. If not, I would encourage you right now to stop watching the video and redo those assignments, or do them again if you've done them in a fast fashion or not completely. Or if you haven't done them at all, do them and then watch this video, because it'll make your life easier and I'll be happy. And remember, I can see, I can feel you. So it's not something I'm saying in isolation. I mean it, and I hope you take this advice. So that was last week. Moving forward this week, I want to emphasize one more thing. Last week we had, between the introduction to the class and the present value, future value stuff that you did, we covered a lot of video. And video watching is very intense. And I want it to be intense because that's how you're learning. However, again, following my philosophy that the amount of time you spend on something cannot be the same for every individual. Similarly, when I create videos, I'm going to let the natural process of that day's session topic drive the length of the video. I will not cross 2 hours. If I do, we'll edit it. But I will not force myself to do 2 hours. It will depend on the nature of the beast. So one warning about today, you got to be an active listener, because we have done some finance, you know a little bit about what's going on. We are going to complicate it, but the complication comes not just because of the formula, but because I'm going to make it more real world. So you got to be engaged, and you got to pause the video if you want to. We'll take some breaks, natural breaks, and I'll try to take them at times where I think it's more convenient to do so for you rather than for me. But I think today will be quite intense. You need to be an active listener and have a Excel spreadsheet with you or a piece of paper with you to follow as we go along, because I'll do a lot of problems. So just a little bit, it's likely to be much more intense than last time. Okay, so let's get started. Okay, today the main issue we'll deal with, put very simply, is the notion of multiple payments. And what do I mean by that? Last time, if you remember, we did do one period, but then we crossed over to multiple periods. But one thing was common to everything we did, whether it was present value or future value. We had one thing to carry forward or back, one payment, one amount of money, one piece of happiness, whatever, just happening, and you're trying to get hold of how to mess around with time. As I said, time travel, if you like it, is what finance is all about. Today we'll go into multiple payments. Why are we doing this? As I said, there's no necessity to do it, except life is like that. Very seldom will you find that you have to make a decision based on a single payment at a single point in time, or single input or output at a single point in time. In fact, life's more interesting issues have something happening today and a lot happening in the future. So for example, when Google was started, I doubt if they said we'll put in so much effort into creating something fantastic which will last only for one period or two periods at best, and things will happen only once. No, they were hoping, and reality proved them right, is that things will keep happening. It'll expand, and time will play a major role for hopefully forever. So the first element of multiple payments which I saw in textbooks is called an annuity. And this is a special case, and annuities we'll call either C stands, by the way, for cash flow, or PMT, which stands for payment, and you'll see why I'm using PMT. PMT is the symbol used in calculators, and PMT is symbol used in textbooks, and PMT is the symbol used for an annuity in a spreadsheet. And it derives from the fact that payments are made back for an obligation. You'll understand in a second. So let me just first show you some terminology. So cash flow, which by the way is being used here simply because I'm going to use a lot of examples where cash is involved. And today another aspect of whatever examples I do after introducing a concept is that they are personal examples. They apply to you personally. We will do a lot of corporate applications of when you start a project in a firm and so on. But this class will start off doing a lot of applications that mean something to you. So if you look over here, this is a timeline, another way of drawing a timeline. And I said timelines are everything. If you could take a word problem and put it on a timeline, that's what we'll do in a second actually, you've arrived. Finance will just make your life so easy after that. So here's what an annuity is. An annuity pays C dollars 3 times in this chart. And something is very important for you to recognize. If you stare at this chart, you'll recognize that nothing is happening at time 0. And when I say time 0, I mean a specific point in time. What is 1? End of period 1, going from 0 to 1. So what is 2? End of period 2, and the period lasts from 1 to 2. What is 3? End of period 3. So one aspect of finance which you have to remember is there are some assumptions built into the formulas that you use. And here the assumption is the first payment of the annuity occurs 1 period from now. And the reason for this is very simple. You'll see in examples that the classic annuity, if you think of an example, what is it? And a classic annuity is a loan. Why? Because you take out some money, your bank gives you some money, and then you pay back. And typically, although you're not required to pay back a fixed amount, you do tend to pay back a fixed amount because the interest rate is fixed and so on and so forth. And we can change all that, but it's very easy to try to understand something that is fixed for 3 periods of time and then change it to the C changing over 3 periods. That becomes easier to do. So what I'm going to do is I'm going to first explain this concept, and I'm going to, as I said, go slow initially and in all the problems too. So let's fill in the cash flow here. I left it open. So this is 0. Nothing is happening at time 0, which is today, right now. So 0, 1, 2, 3 are points in time. Periods of time is 0 to 1, 1 to 2, 2 to 3. And time value of money is simply the existence of an interest rate per period. Okay? So we'll come to that in a second. So suppose I ask you how many years to the end, and you should be able to say that there are 3 years left to the end. How did I figure that out? Very simple. 0 to 1 is 1, 1 to 2 is another 1, and 2 to 3 is the third one. Why am I doing this? I'm just giving you a sense of how many periods are left, right? And usually this is something that should be second nature to you. But many times people start counting. How many periods are there? How many periods are involved? They get confused. Don't worry. How many periods left here? 2. How many periods left here? 1. And how many periods left here? 0. So the thing to recognize is that there is no cash flow occurring at time 0.0, and there is a cash flow occurring at 0.3, which is the end of the period. So those are the 2 things important to recognize. So now let's do the future value of this guy. And before, as I said, I jump into giving you the formula, which textbooks tend to do, and I really don't like that because it doesn't take advantage of your learning that you've already has happened. What is the future value of the first row? Let's do it 1 period at a time, 1 cash flow at a time. Why am I doing that? Because you already know how to do it, right? We did it last time. So what is the future value of this? And I'll do it with you. It has to be 0, because not because time is 3 years are not left, it's because by convention you do not get a cash flow at time 0. That's just it. And the notion is you take a loan and you start paying it 1 period later, right? You do, typically, if you do pay back some today, then the loan is lower, right? Okay, so what's happening in the period 2? Clearly, you're taking C, but for how many periods are you taking it forward? Well, it helps to have column number 3, which says years to the end. So you know it has to be 1 plus R square. Remember, you're carrying it forward. And the reason why it's only square is because the first payment is at the end of the first year. And how many years are left from 1 to 3? 2. It's pretty straightforward. Second payment is C plus R. So what am I doing? I'm actually just breaking up the problem into bite-sized pieces to explain what's going on. So annuity gives you C 3 times, not once, 3 times. Remember, we are talking about multiple payments. And the last one is C. So you see what's going on. It's pretty straightforward, and I'll let you look at this for a second. What's going on is I have 3 C's happening at different points in time. And let me ask you this. If there was no time value of money, how many C's do you have? Answer is very simple. You have 3 C's. And that's what people will tend to do in their heads. In fact, Wall Street Journal, other articles I've read in famous newspapers tend to just approximate and say there are 3 C's. Well, they're not 3 C's. 3 C's at different points in time are a totally different animal than paying 3 C's at one point in time. And that is simply because of time value of money. Okay? So I'm going to move on and show you how to create the formula now. Okay? So again, I'm going to be a little slow in the beginning so that you understand what you're talking about. And so what's the formula? Remember, I'm doing future value of how many payments? 3 payments. And as I've told you before, the one thing not very good about this is my handwriting is pretty awesome. So this is FV, future value. Okay, so what's the future value of the first guy? C1 plus R square. And the first guy occurred in which period? 1. Second, C1 plus R. And the third, C. The one cool thing about an annuity is that I can take C out in common, right? And I can do 1 plus R square, 1 plus R plus 1, right? So let me ask you, what would this be? Remember last time we spoke about how if I got a factor, I can just multiply anything by it and I'll get what I want. Well, this is what? This is the future value factor of what? Not 1 payment, but 3 C's happening 3 times in year 1, 2, 3. At the end of those years, nothing happening at time 0, right? So the general formula, which I will write for you, turns out to be this: C 1 plus R raised to power n minus 1. Why n minus 1? I'll let you figure that out. N minus 1 is very obvious from here. If you stare at this, the annuity was 3 years and this annuity is 5 years. I mean n years, right? So 3 is different from the 2. Similarly, n is different from n minus 1 by just 1 period, and that goes back to the issue I earlier emphasized. This is all happening because of the fact that you don't get any payments, or you don't make, depends who you are. You're the bank or you're the person. Nothing is happening at time 0. And I want you to please understand that convention because it can confuse people. And as I said, the nice thing about finance is there are not too many conventions, right? You don't have to memorize things, but this is a simple one you got to kind of remember and keep in mind, okay? What I'll do is, I won't try to simplify these formulas. There are simplifications available and we can do all of that stuff. What I'll do on the website is I have provided you the short form formulas of all of these if you need to use them. However, we'll jump in class straight to not the final formula, not simplifying things. It's a waste of your time and my time. I think what's much more useful to do is to jump directly into doing examples. We are just doing future value of annuities, and I'll show you now why this is such a cool thing. And what I'm going to do is I'm going to do 2 examples, both for future value of an annuity, and what's the other thing we do? Present value of an annuity. And remember, annuities, the amount of the annuity when you write could be called C, but when you go to a calculator or a spreadsheet, we'll call it PMT because that's what they call it, right? Makes sense. Okay, I would like you to stare at this problem, and I know you have the ability to pause and so on, but I like to pause with you. And what I'm going to do for every example, and if I don't, you should do this, is I'm going to read out the problem for you, and we'll talk about it a little bit. And then I would really encourage you to try to do the problem. I'll do it with you, but I would encourage you to kind of think actively and be participating in it, because I can't see whether you're doing it or not, but I hope you do. Okay. So what will be the value of your portfolio? What is a portfolio? Portfolio, and there's lingo in finance, portfolio means whatever your investment is. wherever you have put your money. So the word portfolio is used generically because you'll see later it's a hangover from the fact that life has risk. And if life has risk and you do not like risk, which most people don't, you tend to not put all your eggs in one basket. So the fact that you hold a basket of different things is called a portfolio. Okay? I'll try to emphasize words which I take for granted because, if you're new to finance, which most of you probably are, you need to understand why certain language is used very commonly. At retirement, if you deposit $10,000 every year in a pension fund, now if you're really young, say you're 15 and taking this class, which I hope some of you are, don't worry too much about retirement. Have some fun. You're in high school. You haven't even begun earning, hopefully. You're just having fun. But this is something that you will do at some point. Most people do. So what I would recommend is just think of it as an intellectual problem, but actually it's a very real problem. So what will be the value of your portfolio at retirement if you deposit $10,000 every year in a pension fund? What is a pension fund? Pension fund is a place or an account which hopefully has multiple assets if you're risk averse, multiple kinds of investments, a bond, a stock, and we'll talk about those. You put $10,000 every year. Why 10,000 fixed amount? Well, nothing is forcing you to put 10,000 every year. It can be 11,000 one year, 9,000 the other. But oddly enough, to make life simple perhaps, many people tend to put away a certain amount of money every year for things they need in the future. So the notion of a pension fund is at some point I'm going to retire and I need some money. So you put away 10,000 every year. You plan to retire in about 40 years and expect to earn 8% on your portfolio. So what have I given you? I have given you everything you need. I've given you PMT or C, which is 10,000. I've given you a number of years left for you to retire, 40. And I've given you an interest rate that you're likely to earn on your portfolio, which means where you put your money. A bank, whatever, we'll talk about that in a second. But let's just focus on this and try to do this problem. I hope you've been listening to me. And I hope you've been paying attention, because if you pay attention to a problem, it gets to be a little intense, and I'll do the problems with you, and I have promised myself today I'll spend a lot of time just doing problems with you, because that's how you learn. And another piece of advice, I've given you textbooks to read that you can go get and read. They can be secondhand, they can be whatever. The fundamental principles of finance have been known since we were in the cave. So it's just remember that what you're trying to do is focus on the fundamentals. So read whatever you want if the video doesn't satisfy your curiosity. But the video is trying to be self-sufficient. So let's do this. Let's now start doing the problem. And what I'm going to do is I'm going to do 2 problems for future value, 2 problems for present value, but I'll take breaks with you. So I'll let you know that maybe it's time to take some time off, get some coffee, go jog around the apartment building where you live, or talk to your friend, or watch a video on YouTube, why not? Okay, so let's get started. I'm going to draw a timeline right here. You can use the box I gave you, or you can use I prefer this. And how many years? 40. So please remember, there's always one more point in time than the number of periods. If you remember that, or if you recognize that, you'll be okay. So how many points in time? 41. 0, 1 through 40. How many periods of time? Well, it takes 2 points of time to make a period, so they're one less. 1, 2. So what we will do to make our life simple is we'll assume that the first $10,000 is at the end of the year. Why did I do that? I could always start saving at this point, but I'm doing it simply so that I can use the formula and just directly, use the calculator and do it and set up. We can change that, so don't worry. You can start a payment today and change it. It's just a minor difference. How much? Another thing that seems a little bit odd or manufactured in this formula is that you're saving at year 42, right? You may not be, right? Or actually you may stop saving in between. So, but for convenience, we are trying to understand a problem which is got 40 of these guys, right? So, the good news is, even though this formula is very complicated, right? You divide this by how much? I mean, you carry it forward by how much? One period, but there's no money. How much do you carry this forward by? 39 periods. How much do you carry this forward by? 38. Which is the simplest piece of this? This guy. Why? Because I'm asking you what is the future value at this point in time, right? So the future value of this point in time of this guy is just itself. That's what I mean. If you learn how to travel in time, if you are at 40 and imagine you are at point number 40, the last PMT or C is $10,000. So at time 40, it's exactly 10. But when you look back, if you were to, you have to carry the past money amounts you've invested is earning money, which is good news for you, right? And it's earning how much? 8%. And let me tell you, that's not bad at all, right? And we'll talk about that when we talk about risk and return in a second. So do you understand the nature of the beast? The beast is not easy. It's not easy. It's like doing 39 future values and adding them up, right? So what I'm going to do is I'm going to now shift to using a calculator, okay? Okay, so if you notice, I'm on the top panel and I'm going to use the formula of PMT. Remember, whatever you don't know, you type in here. So, PMT, right? And the one thing you have to do before you do PMT, and not get excited like me, I'm Mr. Hyper, you have to put equal sign so that otherwise you'll get all kinds of garbage. Okay, you open it up. What is the first number that shows up? The first number that shows up is the rate of return. And we know how much are we earning. We're earning 0.08. Again, emphasizing this, the only reason I'm using Excel right now is what? Simply because the calculation is very difficult. But I've explained to you what's going on. You're doing 40 carry forwards, but actually only 39 because the first one is 0 and the last one is just itself. So that's why I said, okay. So you put a comma and what's the next one? 40. Number of periods, right? And actually, let me just backtrack a little bit. The thing that we want to figure out is FV. So put in FV, and now I want rate 0.08. You see what I was doing, we'll do next time. So number of periods is 40. And in this case, I know my PMT. And my PMT is $10,000, right? And what is PV? Don't worry about it. It's not in there. And just hit OK. So what do you get? And if you get a lot of money, basically, you get $2 million, $2.59 million, right? It's 2590565. So what does this tell you? This tells you that if you invest $10,000 in a bank 40 times, the future value of that will end up being $2.59 million. So what I'm going to do, I'm going to try to talk you through the problem again. So just so that we are working together, what did I do? I calculated future value. So in order to calculate future value is something that I don't know, I have to use the future value function in the calculator or in the spreadsheet. And out popped, I gave this information, $10,000 was PMT, 40 was N, but most importantly, 8% was R. So I gave all this information to Excel or a calculator, whatever you choose to be using, simply because it's a very complicated calculation. Conceptually, it's not that difficult. And we got 2.59 mil. And I'm going to just use it approximately because I'm not going to write all the digits and so on. So what has happened here? Let me just walk you through this problem. First of all, remember yesterday, whenever I asked you, what is the answer to a finance question, or anybody asks you, what should you say? Compounding. But you always have to pause because you want to look smart, right? So you say pause and you say compounding. It's way. So let me ask you the following question. Suppose there was no interest rate, or in other words, how much of the 10,000 are you throwing in? And suppose interest rate is 0. This problem is very simple to do. Why? Because you do 40 times 10,000, you have $400,000, right? So the interest rate time value of money is 0. You will have a lot of money in your bank account, but how much will it be? 400,000. How much do you have if the interest rate is 8%? 2.59 million. Huge difference in magnitude. And who's the culprit? Compounding. In this case, the culprit is helping you. But in the case of if you are paying it, it hurts. So we'll do a loan later. So here it's helping you. So let's talk through this problem a little bit, and so that you understand how empowered you are. How empowered actually you are, and finance will make you feel liberated in this simple problem. So here you go. Let me ask you, who decided the 10,000? Think about it. Who should decide the 10,000 every year? You or your financial advisor? Who? I hope the answer is you. So 10,000, if you have to, I know it's not easy to figure out, but I would encourage you to think about what your needs are in the future so that you can figure out how much you need to put away. And we'll do a problem quite the reverse in a second. So you put away $10,000. Who decides that? You decide that. Second question. What is the other number in this problem? It's 40. How many years to retirement? I know you can say that your job may have a retirement age or so on and so forth, but I challenge you on that. Hopefully, you have much more control on when you retire than you think you do. By that I mean you should keep learning in life so that you always have the opportunity to do something, right? And we are talking about a money problem, but it could be about anything. So let's take the extreme case scenario. You're doing a regular job and you know 40 years from now you're going to retire. My point there is you have more control on that, but sometimes people don't. People have jobs where they are dependent on the employer on how many years they work. But it's a given. I mean, you won't go to a financial advisor and say, in how many years do I retire? The person will give you an answer, but will charge you a lot of money for giving the answer, right? So the 40 is also information that you should know. 10,000 is the information you should know. Now the 8%. I'm going to violate the assumption that I said make it the back of your mind. But to be fair, I never said assume it's not there. I said I know it's there, keep it at the back of your mind, but for the convenience sake, we'll ignore it. And that is risk. So let me ask you this, who determines the 8%? And if you can answer that, you have arrived. And the answer is simply nobody. If anybody knew what the interest rate was in the future for the next 40 years or something, you know, they would be omnipresent, they would know the future. We are all wanting to be like that. But I think the beauty of life is nobody knows. And in fact, one of the most profound developments in finance in recent years, I should recent say last 40, 50 years, which gets challenged because it's a good idea. I mean, bad ideas don't get challenged, right? Good ideas get challenged. So the notion there is that nobody in a good market should be able to tell the future because everything we know is already in the marketplace, right? That's why I said competitive markets at the beginning are extremely important to what we do. So quick question, who determines the 8%? And the answer is you. And this is where I have to bring in risk a little bit. Why? Because 8%, let me tell you, if you get over the next 40 years, may the force be with you. Because it's not going to be easy. You have to take risk to get high rates of return. And with risk comes volatility. So the 8%, the higher it is, the more likely it is that you are jumping all over the place, like the stock market. So if you want to be safer, what will you have to do? You will have to lower the interest rate to say 4%. Put it in a bond issued by the government in the long run and you'll be safer. But what will happen to the 2.59 million? Do this exercise for yourself. Let's, after this class is over, use 4% instead of 8%. And what will you see? A dramatic drop in the amount of money you have at the end. So why am I emphasizing so much in one little problem? Because that's what finance's beauty is, you know. If you understand these problems inside out and you know how to use the Excel spreadsheet to calculate the answers, you have arrived. So if you use 4%, what happens? You kind of get rid of your nervousness about risk. But what happens to the amount of money you have? It'll drop dramatically, right? We know that. We know the power of compounding. It helps when interest rate goes up. It hurts when it goes down. So, having said that, if the interest rate is 4%, you're going to suffer. What can you say about the 8%, 4% choice? Neither one is good or bad. Neither one is good or bad. What's important is you have control over the 4 and the 8 in the following sense. Not that you can predict it, but you, if you choose to put 4% in your calculations, it has to be matched by your investment strategy. So if you're thinking you're going to earn 8% and put it in the bank, especially today, and if this low interest rates go on, you're dreaming. You'll have closer to $400,000 if the bank is still there after 40 years, right? So think like that. Everything is under your control. And the beauty of markets is, for most of us, we do not need to second guess what the interest rates are. All we need to do is match our preferences of risk with our investment strategy and then not worry about it too much. So we've done this problem, and this problem is a PMT problem. However, what's given to you here? The PMT is given to you. You figured it out. Now I'm going to do a future value problem with PMT figuring in, but exactly the opposite. So let's go there. And then I will take a natural break. Okay. So the next problem. Let's just read it. And by the way, if at this point you're feeling a little tired, you've had too much of future value of an annuity, take a break. That's okay, because I think it's much more important you understand bite-sized pieces. And you can always join me in a minute. I'm not going anywhere. I'm here. Okay? Okay. So let's get started with example number 2 of an annuity. So I'm going to again draw a timeline, and hopefully we'll get so familiar with doing this, we are going to I promised myself today that I'm going to go slow and I'm going to squeeze every ounce of energy from a problem. And that's what the beauty of finance is. So 0 here, and how much here? 25. Right? Now, what do I know in this problem? I know that per year, the interest rate again is 8%. Just for simplicity, the same number. The numbers will change depending on who you are. And now I say I know the future value. And I'm using dollars again just for simplicity. Right? So just let's pause. Like last time, I jumped straight into PMT knowing that it's a PMT problem. But it's not the kind of problem that dictates what you're looking for. It is what information you need to be answered. So here, I know future value. So the question is being asked is, suppose you want $500,000 when you retire 25 years from now. How much must you invest each year starting at the end of this year if the interest rate is 8%? Now I repeat again, I'm choosing 8%, but actually you are choosing 8%. Not the exact number, but the strategy. And for 8%, you better be invested in something risky. You're not going to get 8% from the bank. Okay? So $500,000 you need at retirement, right? And you're using 8%. So let me ask you this. When we go to Excel in a second, you will use the PMT function. Why? Because that's the guy I don't know. And that's the guy I'm trying to solve for, right? Okay, let's do it. Okay. The good news is I have the same problem set up over there. But now what do I do? And this actually helps. I have the last problem. What do? I change FV to PMT. Why did I do that? Because as I said earlier, in this particular example, I do not know one of them, and that's PMT. What's the interest rate? 8%. How many years? In the previous problem, it was 40 years, right? In this problem, we have, I believe, 25. And if I make a mistake, that's one of the times you can catch me and fix it faster than me. Okay? So the number of periods, PMT, and then the next information, this is a little bit important because Excel has a system which you got to follow, otherwise you are kind of on your own. If after the number of periods, there is a symbol called PV, which we know what it is. Do we know the PV of this problem? Answer is no. So we got to put 0 because we don't have a number there, and then we type FV, 500. And hopefully when I say, if I have all the numbers right, and I'm doing it in real time with you, simply to make you recognize that you can do it, you can do it just like I did it. The reason I'm using a calculator is simply because the number that I need to calculate has got 25 operations involved, right? So the only operation that's simple is the last one. But in this case, I don't know the last one either. I don't know 25 of them, right? The PMTs. So how do I figure that out? I have to use a calculator or do stepwise, very slowly the problem, and we'd be here forever. Okay, so it's 6,800 and let me call it 6,840. So I'm going to now go back to the problem. The answer to this is in dollars 6840. Why am I making it 6840? Why not 6839.1? Because we are family now. I mean, I'm not going to worry about decimals, and you don't need to worry about them, at least in the classroom. In real life, probably yes. Okay, 6840. Let's, for convenience, assume that it's about 7,000. Approximately, right? So what's going on here? I need to put away $6,840, and I'll approximate it approximately $7,000. How many times? 25 times to end up having 500 bucks, right? So why did I approximate even 6840 by 7,000? Is let me ask you the following question. Suppose the interest rate was 0, right? In other words, there was no value to time. What would you have if you invested $7,000 25 times? You just multiply 7,000 by 25, right? So what do? You take $7,000 multiplied by 25, you have 175, 75. Why did I do this? Again, as in finance, pause and say, compounding, right? So if I didn't have 8% rate of return, I would have only $175,000. That's not little, and by no means am I saying it's throwaway money. But compare the 175 to the 500. So what's going on? The 8% is helping me, and here's my little take before we take a natural break on this. I hope you understand this problem. Secondly, I hope you recognize that the 8% is coming from where? The market. And I hope you realize now why the market is so awesome. Because you're not doing anything. I'm not doing anything when I put away my money in my retirement. What am I giving in this example? I'm putting away 6840, right? I understand that could be my hard-earned money. But the fact is, the externality, the positive benefit a market provides to people for their ability to benefit from the economy at the rate of 8% is phenomenal. You see what I'm saying? So what's going on here is that my money goes to somebody with great ideas who's able to earn some money, and I still can earn 8%. So I don't want you to ever forget the beauty of markets. Beauty of markets is an ability for all of us to share, and not one person, all of us. And that's the beauty of it. The unfortunate thing about life, as I said, once in a while I'll go into life, is that not everybody has this opportunity. And yes, we can all say that everybody's not working hard enough, but sometimes it's difficult to make money, right? It's difficult to have jobs. A lot of people these days don't have the ability to even invest. So let's do this. Let's take a break right now. We have spent a lot of time on two problems. I do not want you to exhaust yourself, but I want you to think about these issues. One last thought. While we are offline, redo these problems and double check them. Let me explain what I mean. Make 6840 your payment. Make number of years 25 and make the interest rate 8%. And solve the problem for what the future value will be. And what should the answer be? 500,000. Tell me what's cooler than that. It's internally consistent. It's got to be. If it's not finance. Okay, so take a break, and I'll also take a pause, and we'll come back and start off with present value of annuities. Keep smiling. Thank you. I hope you have taken a break and gotten familiar with what we are doing. As I said, today is going to be intense because I want you very early on in this class to really get a feel for finance. I mean, to me, the beauty of finance, as I keep saying so, is not the formula. It makes so much sense. And once you get a hang up of why we are using an Excel and why we are doing the formula, you'll get a sense of that, and it'll be very, very easy for you to recognize the value of each. I have nothing against Excel, but here's a simple reason we use Excel. Is because we don't have time to calculate all these numbers. We know how to do it, but we don't have the time. And it would be a pretty bizarre thing to calculate numbers for the heck of it. The second reason is these cash flows in this problem are fixed. They could change. That's what life is, and we'll do that later in the class. But two aspects about it. Most examples of loans or retirement funds are very realistic in this respect too, i.e. the C is fixed. People choose to operate like that, whether it's convenience, whatever, and loans many times are fixed rate loans. So what I would encourage you to do is recognize that these are simplifications at some level, the C being a fixed number, but at the same time see it's not a simplification of real life. And we'll get to more complicated things. Why am I bringing this up? Because if we didn't have compounding, we wouldn't need Excel. And if we didn't have things changing over time, we wouldn't need Excel. So Excel is awesome, but keep it where it is. It's not controlling you, you control it. Okay, let's move on to the second phase of an annuity, which is present value. So again, there's this chart, I would like you to look at it for a second. Same thing, just to make life simple, what I'm going to do is I'm going to stick with the same example of 3 years. And by the way, as I'm doing this, I want to thank, instead of just thanking once, I want to multiple times thank my colleagues. I went to University of Chicago for my PhD, and before that I've studied a lot. I have to thank so many people for showing me the beauty of finance. I also want to thank my colleagues at University of Michigan, Ross School of Business. Ronan Israel is one of them who, with me, taught this introductory class many, many years ago. And he has been a big influence in how I think. And then there are a lot of other colleagues like MP Narayanan, who's a great teacher. I want to thank all these guys for letting me become who I am. And if I'm worth anything, it's due to other people, not due to me. Okay, so let's get started. The first cash flow at year 0 is 0, and not because it's forced to be, it's convention. And in this case, remember, because it's present value, I'm standing today, I'm doing the opposite of future values. So I'm saying not years to the end, years to discount. And the word discount is coming from a very simple reason, and the R is greater than 0. Because interest rates are positive, future value grows. But because interest rates are positive, the future is discounted when you bring it back today, right? So how much? 0 years of discounting, because we are standing today and present value today is 0. What is the present value? Turns out to be 0. Why? That's simply because there's no cash flow here. If there were, it will be exactly the same number because of no years to discounting. So in some sense, years to discounting is a key variable. Now here, things are a little bit simpler. 1, the first C is 1 year away. 2, 3. So because we have done this table before, I'm not going to spend too much time on it. However, recognize that we are doing the exact opposite of what we did last time. And the reason we are doing present value after future value is, in my book, if you understand future value, you understand compounding. And then when you come backwards, you're not thrown away by why you're dividing by 1 plus r squared. So let's do it. This is C over 1 plus r. And the neat thing is we have done this last time. Only thing is we have to do it 3 times. C. Why am I putting 1 plus r each time in parentheses? Simply because it's the 1 plus r is the factor, not 1 outside or r outside, anything like that. 1 plus r is the factor. And the reason it's getting squared and cubed is because, pause again, compounding, right? So once you recognize this aspect of it, I want you to bear with me for a second. And what I'm going to do is I'm going to go to another page where I actually write out the formula. And again, I'm not going to try to simplify it. Simplifications can be done very easily by you, and in some sense it's useful to do it. So let me write out the present value formula. Present value formula for a 3-year annuity, and I use this 3 just to remind me that it's just 3 years, is what? C over 1 plus R plus C over 1 plus R square plus C over 1 plus R cube, right? So I have just to do 3 PVs. Now remember, these PVs are not easy to do, right? So that's why I'll at some point use a calculator. And remember, I can replace this by PMT in my head. In textbooks, we don't use PMTs, we say C because C is a generic word for cash. The other thing is C's are fixed, and that's because of the nature of the beast we are dealing with right now. Okay? Now let me show you that actually I can take C out and have right? Pretty straightforward. So what is this? If you think about it a little bit, this is a factor again. And it's a present value factor of an annuity. Of what? What is the annuity? $1. So if you know the present, if you know this guy, for which what do you need to know? R and N. How many years and what's the interest rate? If you know the value of $1 paid 3 times, you can know the value of C bucks, whether it's half a buck or it's $100. That's the beauty of it. How does this formula change if we go to PV of N? Simple. One thing changes. There's a bunch of dots plus 1 over 1 plus R raised to power N. So you'll keep going till you arrive at N, right? I hope this is clear. Again, why am I doing this? I first did the concept, then the formula, but I'm really, really interested now in doing problems. And again, I repeat, if you need to pause now, it's good to do it because I do not want you to get overwhelmed by formulas and so on, okay? So let's go on, and I'm going to even pause for a second to remind you, you don't have to keep watching the video. Take a break and let's do one problem at a time. Okay. The first example I'll do of a PV of an annuity is just like a future value. I'll give you the annuity and I will ask you to calculate the PV. So let's read the problem very carefully. How much money, and just so that I can write on this. You see I press a button here to be able to write all over and then go back. So I do a lot of cool things that you can't see. Okay, anyway, so I love technology, and there's a person here sitting next to me who's an awesome person, and without him I wouldn't be doing this, honest. How much money do you need to put in the bank today so that you can spend $10,000 every year for the next 25 years, starting at the end of this year? So think about this. What kind of problem is this? This is a problem where you need money today and you are thinking about using it and depleting it over time, right? So suppose the interest rate is 5%, and I think we are becoming very real with interest rates. We've gone from 8 to 5 now. That's where the real world looks like right now. So what I'm going to do is I'm going to draw a timeline. And I'm sorry, this is something I'll force you to do. And another use of Excel is it comes with a timeline, with the A cell being 0 and so on. Okay, so 25, 0, 1. So remember, more points in time by 1 than the number of periods, right? So what do I know here? I'm standing here. What do I know? I know that I need $10,000 25 times, right? So this to me is C or PMT. So I know PMT. But what do I want to figure out? Okay, I need to spend $10,000, but I need to have it in my bank because maybe I just want to retire. Or maybe over the next 25 years I'm working, but I want $10,000 set aside for some needs that are important for me. Whatever the motivation you've decided to do this, I will have to figure out PV. Now, if I did it the long way, what will I have to do? 10,000 divided by 1 plus R, right? Story is not over. What do I have to do? 10,000 divided by 1 plus R square. And how many times? 25 times. Now, if I had to do the same thing 25 times, life is easy. But again, who's messing with my fun? Compounding. Because every time I add another one, this 2 becomes a 3, 4, 5, 25 times. Okay? So what do I have to do? When in desperation for calculation, go to Excel. Okay? So I'm going to go to Excel, and the good news is the previous problem is already there. So I do not want to do a PMT first because I already know PMT, but I want to do now what? PV, right? Interest rate is now not 8%, but it's 5%. How many years left? I believe in our problem that we were looking at, let me confirm what it is. We do have 25 years left, and so we are okay on that. What is the PMT? Well, I know my PMT. And I'm going to remove that last element because it's not needed. So let's say, so 140,939 and 45 cents. So what does that tell me? I better have $140,939 in the bank to satisfy the need of spending 10,000 in the future. So let me go back to the problem and tell you what's going on. So I need in the bank 140,939, and let me just for convenience call it $141,000, right? So let me ask you this. If I spend $10,000 every year and the interest rate was 0, right? How many times will I spend 10,000? 25 times 10 is 250,000, right? So the number that I'm going to put in the bank is nowhere close to 250. It's off by at least 110 approximately. Why is that? Because when I put $141,000 in the bank, the world is helping me. The ingenuity of the world is helping me in the form of 5% rate of return, right? So the good news here is when you do PV in this case, you have to put much less than what you need in the future, simply because as the money is being withdrawn, the remaining money is growing in value because again of the positive interest rate. So is this problem gives you a sense of how to do PV. And remember, the PV is discounting. So every $10,000 in the future is becoming less so today. And the last $10,000 is being discounted by 25 years. So what happens is you are not multiplying 10,000 by 25 to get this answer. Because of compounding and a positive interest rate, you're getting an answer of $141,000. I would encourage you to do this in your own time. Try to, after we are done with this class, see how much money are you left with at the end of 25 years if you carry this money forward. And we'll do this in a context. And why am I encouraging you to think like that is simply to confirm that this number is right under the assumptions. One final comment before we move on to the next problem. The interest rate is 5% here. So if the world is the same as our previous problem, it requires a strategy that is less risky than the 8% to follow. So just wanted to bring that risk thing that's at the back of your mind into the picture, just to show you, you know the 10, you know the 25, and basically you know the 5. Of course, the 5 won't be 5 the more risk you take, but that's true about anybody making the investment, right? So please remember that. This problem helps you a ton. What I'm going to do now is, if you want to take a break, this is a natural time. But I'm going to, because we've become familiar with doing these kind of problems, I'm going to take the next problem example on right away. But as I said, I always take pauses for you to take ownership. In spite of the fact that you could pause me anytime, I think it's good for me to tell you what I think would be a good time for you to pause. Okay guys, now I'm going to do a problem on which I will spend a lot of time. And why am I doing this spend a lot of time? You'll see this is a classic finance problem in a real world sense. So here goes the problem, and please read with me. I'm going to try to highlight things as I go along. You plan to attend a business school and you will be forced to take out $100,000 in a loan at 10%. And the 10% you'll see is kind of artificial because I want to make my life a little easy here. Hopefully you don't need to pay 10%, you need to pay much less. But the 100,000 is a fact of life. It costs about that much for 2 years worth of tuition. And I teach at the business school, and clearly I benefit from the value provided by business school education and people's willingness to pay. But I want to emphasize this is not a small number. And remember, when you come to school, you're also giving up an opportunity of working. So when you do your calculations to go to school, it's not a minor thing. And being in education, a part of me really believes that things like this class I'm doing should be a large part of the future. Of course, it brings up the question is, how do people survive if everything is for free and so on. But I personally feel this 100,000 number is a bit too high, even if I benefit personally from it. Anyway, you want to figure out your yearly payments given that you will have 5 years to pay back the loan, right? So what do I know? We call this guy N. We call this guy what? PV, FV, PMT. Well, we call it PV. Why? Because when I walk out with the bank, from the bank with $100,000 of loan, I have the money today. But what do I have to do? In this case, pay a hefty 10%. But I emphasize again, the good news is the interest rate is not that high and should not be that high. Let me throw in the word should there too, because simply because it's just too high for many standards. Anyway, so at 10%, simply because you'll see later, it'll help us with the calculations. So the first question to ask ourselves is, let's draw the timeline. And in this case, there's 5, 0, 1, 2, 3, 4. Now I'm going to ask you, is this a real world problem? And if you tell me no, I think the issue is with you, not with me, right? This is a real world problem. The only thing that will change is the numbers, right? So the quick question to you is, who decides 100,000? 100,000 is here. Who decides it? Well, all of us collectively. The fee is determined by the school or the university, wherever you're going, and the amount you need to borrow depends on your ability to finance the education, right? So you'll borrow, let's assume you'll borrow 100,000, which is 2 years worth of tuition, and of course you need to spend money on yourself too. Let's keep that aside for a minute. Who decides the 10%? This is a very interesting question and goes back to my emphasis on markets. If it is one person in the whole market deciding the interest rate, that person is called a monopolist. And if in finance or borrowing and lending money, there is one person, you know who will get screwed? Us, the customers or the people borrowing money. So that's why competitive markets are important. Competitive markets are important so that the consumer benefits, not the producer necessarily. And by the way, all of us are the same people. It's not us versus them. I'm just emphasizing that markets are for people. Markets are not for one person or a few of us, right? That's the beauty of markets. Anyway, so the 10% hopefully is coming out of competition. Why? Because if there are 3 banks, you'll always go to the lowest interest rate, right? So competition among banks on the internet hopefully is getting better to help you get a reasonable interest rate. So R per period is 10%. And how did you decide 5 years? Well, it's again an interaction between you and the bank, and interest rates will vary depending on the periodicity or the length of the maturity of the loan and so on. So let's keep that issue right now in the risk category, right? So you have 5 years to pay it back. And the question I'm asking is what? How much will you pay every year? Per year. Right? So let's do this problem. And to do this problem, I have to go to Excel, and I'm going to now try to do things a little quickly on Excel. So let's do it without screwing things up, obviously. So what was our problem now? I know my PV, and I'm going to calculate what? PMT, right? This is a number I should know, and the bank should tell me. So the interest rate is how much? Interest rate is 10%. And how many years? Not 25, 5. And the next number is PV, fortunately, if I see it right. Yep. And you've got to keep your eye on the ball. And how much did I borrow? 100,000. Right? So huge number. So the answer to this question is 26,380. And I think what this is telling you is, and I kind of rounded things off again without decimals, it's telling you that I or you, whoever is borrowing the money, will get $100,000 today, but will have to pay $26,000 plus 380 5 times. So just pause there. This looks like a huge number. Now, the number, don't get fixated on the number. If you were borrowing 10,000, it will be less. If you were borrowing 50,000, it will be less. If you're borrowing 1 million, the payment will be more. But there is a one-to-one relationship between what you're borrowing and what you have to pay. So let me ask you this question. Suppose the interest rate was 0. Suppose you could go to the bank and just get $100,000 and not pay any interest. How much would you pay every year? Pretty simple. Take $100,000 and divide by 5. In this case, you're paying 6,380 more every period, every year. And for simplicity, we have kept the year as a fixed quantity, not a month. We'll get to that in a second. So what I'm going to do now is I'm going to take the 26,380 and do this. What should be the present value of this with N5 R of 10%? What should be the PV? If you can answer that question, you know how to mess with Excel. Actually, you know how to do something very profound. If you do this exercise, which I encourage you to do, it has to be $100,000, right? Because you're just going back and forth with the same problem, okay? So $26,380 is the amount of money that you'll have to pay every year on a loan. What I'm going to do next, and I'm going to take a break now, and I think you need to take a break, is you know how to do this problem. I'm going to now use these problems to show you how great and awesome finance is. And after that, I will do a couple of other problems and get you completely internalized with the class today. As I had promised, the class is intense because I'm doing problems. I'm bringing in the real world. If I were just doing the formulas, you'd be much happier because time would just be passing by quickly, but the learning, I believe, won't be the same. Okay? So let's take a break. We'll come back and deal with this issue in a second. Hello, welcome back. Hope you have had the chance of now doing 4 problems at your own pace. And today, as I said, is going to be intense because we are trying to pull in a lot of real world stuff. And I'm trying to tell you the meaning of every bit of information to the extent I can. So take your time, and now let's use this one simple example to show you the awesomeness of finance. I really mean it. If you hang on to the next half hour or so and listen carefully, we'll be in good shape. Okay, so what is a loan amortization table? First of all, I told you last time that the loan example is a classic example of what a finance instrument looks like, or what finance is all about. So what I'm going to do here is I'm going to take the same problem. How much did we borrow? $100,000. So I'm going to write $100,000 here. And the reason I'm writing $100,000 is because that's the amount of money you started off with. I want you to recognize that the amount at here, the title here, is beginning balance. Why did I say that? Because that's the amount of money you have walked away with, or you owe the bank at the beginning of which year? Year 1. So what point in time is this? It's time 0. Point in time 0. So that's why whenever beginning, it's said so, because otherwise it's assumed things are happening at the end of the year, right? So please be very clear that if I draw a timeline, the $100,000 is at time 0. And who has paid you this? The bank. So you have it. Now what do you have to do? Pay. So the first payment will occur when? At the end of the year. It won't occur here, it will occur here. And we know it's 6,380. The good news is that this, for convenience and very common in the real world, is what is called a fixed interest rate loan. So the interest rate was 10% for convenience, you'll see why. But the good news is right? So the yearly payment starting with this year is, I'll write 26K for convenience. It's about 26,000, right? So what is an amortization table and why am I doing it? Because it brings out the essence of what's happening during the life of the loan. And I think it's very important for you to time travel. If you know how to time travel, you'll understand finance. So right now you are here, and let's begin time travel. At the end of the first year, what did we do? We paid 26,380. Let's break it into 2 parts. The first part is the interest, and we know the interest is 10%. But remember, the weakness of an interest rate, if there is any, it's not in dollars. It's not in the form of valuation that you're used to, dollars, yen, and so on. So how much will it be? I'm going to pause for a second. This is not a difficult problem, but people get stuck with it. It has to be 10% of what you borrowed. And how much is that? Sorry, 10,000. Is that clear? This is very important. You owe interest on what you borrowed at the beginning of the period, and 1 year has passed and you owe 100,000 at the beginning, so you owe 10,000. So how much will you repay the loan? Remember, because the goal here is not only to pay interest, but to repay the loan. So how much is left? Very simple. If you are paying 26,380 and you are paying $10,000 interest, how much is the loan repayment? Straightforward. Take this, subtract this, you are left with 16,380. Now you know why I took 10%. I took 10% because I'm doing this problem with you. I'm not using a calculator. In real life, that's why Excel is great. You can do, instead of 10%, you can have 0.2, 3, 4, 5, whatever. So now the next step is a little bit important. And the question is, how much will you owe the bank at the beginning of year 2, which is which point? Remember, beginning of year 2 is 0.1, end of year 2 is 0.2. So at this point, how much will you owe? Very simple. You owe 100,000. You paid the use of money 10%. You would love to deduct it from how much you owe, but a hand will come out of the bank and hit you and say, what the heck are you doing? This is for the use of money. On the other hand, the bank would love for you to pay all 26,800 as interest. Of course, if you're silly enough to do that, the bank will thrive, right? So it depends who's being silly or stupid here. Okay, so this is the amount you repay. So what do? You subtract this from this. And how much are you left with? Just to make sure I'm getting the numbers right. Everybody got it? So what has happened? I have lowered the amount I owe because I paid 26 and only 10,000 was the interest, right? Now at the end of the second year, what do? I again pay 26K. Now what is going to happen? Take a guess. Will the amount of interest go up relative to last year that you pay or go down? Think about it. If the amount went up, you're going in the wrong direction. The only way the amount would go up on interest is if you had actually borrowed more rather than paid back some. And there's no good or bad here. Here the assumption is that you're going to pay back the loan, right? So how much will you pay in interest? Pretty straightforward. 8, 3, 6, 2. How did I do that? Pretty straightforward again. The interest rate is 10%. I took the 10% and I didn't multiply it to the 100,000. I multiplied it to 83,620. Why? Because I don't owe the bank 100,000. I owe the bank only 83,000 at the end of the first year. The good news is my interest has dropped. Yep. But the reflection of that good news is that I'm paying back more. So if I paid back 16,380, how much am I paying back now? More or less? Answer is, if the interest amount is dropped, the repayment amount has to go up, assuming that I'm paying back the same amount, 26K or so every year. So the answer to that is 18,018. For the ease of saving time, I've just done these calculations ahead of time. And so how do I know that? I know that 18 plus 8 has to add up to 26. Because 26 is what I paid again, that end of year 2. So at the end of the year 2, what is happening? My interest rate is going down, but my repayment rate is going up. And this is needed for you to repay the loan, right? So here's your homework number 1. Before you do anything else, try to fill up this box. And I will do it quickly for you. But the principle is the same. How do I go from here to here? I subtract this from this. So let me write the number for you. 65,603. How do I go from here to the interest column? 10% of this. So 6560. And how do I get this column? I know that the number has to increase because this dropped and this amount is the same. So 26 is the same. So I subtract 6,500 from 26, I get 19,820. Okay? Same thing, let me just write it out, 75,783. This number drops to 4,578. This number goes up to 21,802. This number becomes 23,982. This number is 2398. And the last number is 23982. So see what's happening now. At the end of the year, how much did I owe 23982? But I paid 26380. You see, I owe 23982, but I paid 26380. Why did I pay more than I owed? Because I owed 23982 at the beginning of the year, and I have to pay interest on it of 2398. So I have to pay 26380 to be able to pay back the loan. But the good news is, when I'm done in year 5, how much do I owe the bank? Nothing. Again, I'm saying it's good news consistent with your plan to pay off the 5 years. In finance, the good news is there's no good news, bad news. It depends on what your objective is. So, for example, if you don't have money, many times you don't have money coming in, people take interest rate only loans. That's okay, because if it's dictated by the cash flow constraints you have, you pay less because you're only paying interest. But most people want to pay off the loan, therefore this example is very, very valid. Okay? So please remember this, do this example one more time. Why am I going to emphasize this, and where does the beauty of finance come in? And now bear with me for a second. What is the first column showing? The year. What is the second column showing? Beginning balance. The yearly payment, interest and principal payment. Suppose I walked up to you and asked you, hey, you've taken a loan, $100,000, you're just coming out of the bank, and I'm your buddy, and I know you know finance. I say, how much did you borrow? I said, $100,000. I say, look, can you tell me how much will you pay the bank every year for the next 5 years? Will you be able to do that? Sure. You have an Excel spreadsheet with you, you're sitting in the car, you open it up and you do a PMT calculation and you can come up with 26,380. Easy. So the good news is, once you know how much you're borrowing, the yearly payment column, if at a fixed interest rate, is very straightforward. But what is the most difficult part of this problem? The most difficult part of this problem is the following answer to the following question. If I were trying to figure out whether you really know finance and the awesomeness of it, I'll ask you the following question. How much will you owe the bank? How much will you owe the bank at the beginning of year 3? At the beginning of year 3, which is also the end of year 2. Right? So how much will you owe the bank at the beginning of year 3? How will you do that problem? So this is where, if you did this problem this way, it'll take you ages to do. Because I could ask you the question, how much will you owe at the beginning of year 4? Look, to get there, what will I have to do? If I were to say, how much do you owe the bank at the beginning of year 4? I'll have to go through many rows of this spreadsheet to be able to understand. And this is where the beauty of finance comes in. And I'm going to try to show you a timeline which is very similar to this one, and I'm going to call it, instead of amortization, I'm going to call it the power of finance. So let me start off with a simple question. If I asked you to tell me, how much do you owe the bank here? Remember, this is the beginning of which year? First year. What point in time? 0. Now, it's a silly question to ask, but not quite. Why is it a silly question to ask? Because you already know how much you've borrowed, which is what? $100,000. But let me ask you this. As soon as you walk out of the bank, this is something that the bank will tell you. Believe me, it will. That you need to pay how many times? 5 times. Right? Right? So you walk out of the bank, you know the yearly payment, and I ask you the following apparently silly question. How much do you owe the bank the moment you walk out of it? You know what many people will say? Many people will multiply 26,380 by 5. And you have just destroyed me. if the answer is that. You might as well take a big knife and stick it in my stomach. And the reason is you cannot add or multiply over time because of compounding and a positive interest rate, right? Because if you do, how much do you owe? You owe 20,000 5 times if interest rate was 0. So your answer is not a good one. So here's what you do. You make 26380 5 times a PMT, right? And what do you make n? 5. Yes? Because you owe 5 of these. What is the only other number you need to do? R, which is what? 10%. If you do this problem, what button do you need to, or what execution in Excel or a calculator do you need to do? Well, to figure this out, you have to figure out PV. Please do it. I wish your answer will work out to be 100,000, right? We know that. Why am I emphasizing this? Because the awesomeness of finance comes from the following simple principle number 1. All value is determined by standing at a point in time and looking forward. You can do value in many different ways. You can do it at time -5 and bring it forward, or do it in the future. But the best way to think about decision making is you're standing at 0 and you're looking forward. So when you're standing at 0 and looking forward, how many payments of 26,380? 5. Each one separated by 1 year. The first one starting in which year? End of the first year. And when you do the PV of it, you better come up with 100,000. And this is one of the most profound Nobel Prize winning points. Please keep it in mind, we'll come back to it later, which is the following. You cannot make money by borrowing and lending. Right? If the present value of 26,380 was different than 100,000, somebody's made a fool of. So suppose the bank gives you more than $100,000. The bank is being an idiot, and let me assure you that won't happen. If you walk off with less, somebody's shafting you. So the question here is, how does the bank then make money? Well, it makes money by charging you a little bit more on the borrowing lending rates difference. They have to feed the family too, right? They work for you. They create the market. But that's the friction I was talking about. But value cannot be created by borrowing and lending. Otherwise, you and I would be home and creating value. Yes, it grows over time, but the present value is still the same as the money I put in, right? That's a very fundamental point in finance. Value is created not by exchanging money, which is this, borrowing and lending. Value is created by coming up with a new idea for creating value for society, right? So that's what I'm trying to say. So let me ask you this. How much will you owe the bank at the beginning of year 2? What would you have to do? You would have to calculate the interest rate, you would have to calculate the principal payment, and then you subtract it from this. Answer is very straightforward. And this is where I love finance. Just change one number. Make this 4. So change the 5 to 4 and do the PV. What will you come up with? Please do it. You will come up with 63280. So what have I done? Instead of sticking with time 0, I have time traveled to period 1. If I'm at period 1, I've already paid this up. How many more left? 4 left. So n is 4 and interest rate is 10%. And how many am I paying? 26,380. So 83,620 is very easy to do if you recognize that. So how would you do the next column? It's 65,603. How will you do it? You'll just make n 3. So you see what I'm saying? What I'm saying is the simplest thing in finance is don't get hung up on the past. Get hung up whenever you are asked about value of anything, whether you owe it or you're getting the value. Look to the future and the problem becomes trivial. Why? Because if you know all these values, these are just 10% of this. So this is just 10% of this row, and then this is just These two added together is this. So if I add these two, I get this. So I can do this in a second as opposed to doing it over an amortization table. So one more time, if I were to ask you to do this problem all over again, what would you do? You won't use any prop. You only Excel to solve the problem. So if I asked you, how much do you owe in a particular year to the bank, which is a very good question to ask, you will just do what? You will time travel, right? You remember Matrix? Jumps across two buildings. First time is not successful, but that's life. But then manages to jump across, right? And if you haven't seen Matrix, see Matrix. It's much more interesting than this problem. So time travel to year, whatever forward, look forward, how many payments are left, just do the PV. Okay? I hope you like this, because this is, if you remember this is finance. Compounding plus this is most of what finance is all about. So it's a mindset. You always look forward. Okay? Hello, welcome back. I hope you have had the chance of now doing 4 problems at your own pace. And today, as I said, is going to be intense because we are trying to pull in a lot of real world stuff. And I'm trying to tell you the meaning of every bit of information to the extent I can. So take your time, and now let's use this one simple example to show you the awesomeness of finance. I really mean it. If you hang on to the next half hour or so and listen carefully, we'll be in good shape. Okay, so what is a loan amortization table? First of all, I told you last time that the loan example is a classic example of what a finance instrument looks like, or what finance is all about. So what I'm going to do here is I'm going to take the same problem. How much did we borrow? $100,000. So I'm going to write $100,000 here. And the reason I'm writing $100,000 is because that's the amount of money you started off with. I want you to recognize that the amount at here, the title here, is beginning balance. Why did I say that? Because that's the amount of money you have walked away with, or you owe the bank at the beginning of which year? Year 1. So what point in time is this? It's time 0. Point in time 0. So that's why whenever beginning, it's said so, because otherwise it's assumed things are happening at the end of the year, right? So please be very clear that if I draw a timeline, the $100,000 is at time 0. And who has paid you this? The bank. So you have it. Now what do you have to do? Pay. So the first payment will occur when? At the end of the year. It won't occur here, it will occur here. And we know it's 6,380. The good news is that this, for convenience and very common in the real world, is what is called a fixed interest rate loan. So the interest rate was 10% for convenience, you'll see why. But the good news is right? So the yearly payment starting with this year is, I'll write 26K for convenience. It's about 26,000, right? So what is an amortization table, and why am I doing it? Because it brings out the essence of what's happening during the life of the loan. And I think it's very important for you to time travel. If you know how to time travel, you'll understand finance. So right now you are here, and let's begin time travel. At the end of the first year, what did we do? We paid 26,380. Let's break it into 2 parts. The first part is the interest, and we know the interest is 10%. But remember, the weakness of an interest rate, if there is any, it's not in dollars. It's not in the form of valuation that you're used to, dollars, yen, and so on. So how much will it be? I'm going to pause for a second. This is not a difficult problem, but people get stuck with it. it has to be 10% of what you borrowed. And how much is that? Sorry, 10,000. Is that clear? This is very important. You owe interest on what you borrowed at the beginning of the period, and 1 year has passed and you owe 100,000 at the beginning, so you owe 10. So how much will you repay the loan? Remember, because the goal here is not only to pay interest but to repay the loan. So how much is left? Very simple. If you are paying $26,380 and you are paying $10,000 interest, how much is the loan repayment? Straightforward. Take this, subtract this, you are left with 16,380. Now you know why I took 10%. I took 10% because I'm doing this problem with you. I'm not using a calculator. In real life, that's why Excel is great. You can do, instead of 10%, you can have 0.2345, whatever. So now the next step is a little bit important, and the question is, how much will you owe the bank at the beginning of year 2, which is which point? Remember, beginning of year 2 is 0.1, end of year 2 is 0.2. So at this point, how much will you owe? Very simple. You owe 100,000. You paid the use of money 10%. You would love to deduct it from how much you owe, but a hand will come out of the bank and hit you and say, what the heck are you doing? This is for the use of money. On the other hand, the bank would love for you to pay all 26,800 as interest. Of course, if you're silly enough to do that, the bank will thrive, right? So it depends who's being silly or stupid here. Okay, so this is the amount you repay. So what do? You subtract this from this. And how much are you left with? Just to make sure I'm getting the numbers right. Everybody got it? So what has happened? I have lowered the amount I owe because I paid 26 and only 10,000 was the interest, right? Now at the end of the second year, what do? I again pay 26K. Now what is going to happen? Take a guess. Will the amount of interest go up relative to last year that you pay, or go down? Think about it. If the amount went up, you're going in the wrong direction. The only way the amount would go up on interest is if you had actually borrowed more rather than paid back some. And there's no good or bad here. Here the assumption is that you're going to pay back the loan, right? So how much will you pay in interest? Pretty straightforward. 8,362. How did I do that? Pretty straightforward again. The interest rate is 10%. I took the 10% and I didn't multiply it to the 100,000. I multiplied it to 83,620. Why? Because I don't owe the bank 100,000. I owe the bank only 83,000 at the end of the first year. The good news is my interest has dropped. Yep. But the reflection of that good news is that I'm paying back more. So if I paid back 16,380, how much am I paying back now? More or less? Answer is, if the interest amount is dropped, the repayment amount has to go up, assuming that I'm paying back the same amount, 26K or so every year. So the answer to that is 18,018. For the ease of saving time, I've just done these calculations ahead of time. And so how do I know that? I know that 18 plus 8 has to add up to 26. Because 26 is what I paid again, that end of year 2. So at the end of the year 2, what is happening? My interest rate is going down, but my repayment rate is going up. And this is needed for you to repay the loan, right? So here's your homework number 1. Before you do anything else, try to fill up this box. And I will do it quickly for you. But the principle is the same. How do I go from here to here? I subtract this from this. So let me write the number for you. 65,603. How do I go from here to the interest column? 10% of this. So 6, 4560. And how do I get this column? I know that the number has to increase because this dropped and this amount is the same. So 26 is the same. So I subtract 6500 from 26, I get 19820. Okay? Same thing, let me just write it out, 75,783. This number drops to 4578. This number goes up to 21802. This number becomes 23982. This number is 2398. And the last number is 23982. So see what's happening now. At the end of the year, how much did I owe? 23982. But I paid 26,380. You see, I owe 23982, but I paid 26,380. Why did I pay more than I owed? Because I owed 23982 at the beginning of the year, and I have to pay interest on it of 2398. So I have to pay 26,380 to be able to pay back the loan. But the good news is, when I'm done in year 5, how much do I owe the bank? Nothing. Again, I'm saying it's good news consistent with your plan to pay off the 5 years. In finance, the good news is there's no good news, bad news. It depends on what your objective is. So, for example, if you don't have money, many times you don't have money coming in, people take interest rate only loans. That's okay because if it's dictated by the cash flow constraints you have, you pay less because you're only paying interest. But most people want to pay off the loan, therefore this example is very, very valid. Okay? So please remember this, do this example one more time. Why am I going to emphasize this? And where does the beauty of finance come in? And now bear with me for a second. What is the first column showing? The year. What is the second column showing? Beginning balance. The yearly payment, interest and principal payment. Suppose I walked up to you and asked you, hey, you've taken a loan, $100,000, you're just coming out of the bank and I'm your buddy, and I know you know finance. I say, how much did you borrow? I said, $100,000. I say, look, can you tell me how much will you pay the bank every year for the next 5 years? Will you be able to do that? Sure. You have an Excel spreadsheet with you, you're sitting in the car, you open it up and you do a PMT calculation and you can come up with 26,380. Easy. So the good news is once you know how much you're borrowing, the yearly payment column, if at a fixed interest rate, is very straightforward. But what is the most difficult part of this problem? The most difficult part of this problem is the following answer to the following question. If I were trying to figure out whether you really know finance and the awesomeness of it, I'll ask you the following question. How much will you owe the bank? How much will you owe the bank at the beginning of year 3? At the beginning of year 3, which is also the end of year 2. Right? So how much will you owe the bank at the beginning of year 3? How will you do that problem? So this is where if you did this problem this way, it will take you ages to do. Because I could ask you the question, how much will you owe at the beginning of year 4? Look, to get there, what will I have to do? If I were to say, how much do you owe the bank at the beginning of year 4? I'll have to go through many rows of this spreadsheet to be able to understand. And this is where the beauty of finance comes in. And I'm going to try to show you a timeline which is very similar to this one, and I'm going to call it, instead of amortization, I'm going to call it the power of finance. So let me start off with a simple question. If I asked you to tell me how much do you owe the bank here? Remember, this is the beginning of which year? First year. What point in time? 0. Now, it's a silly question to ask, but not quite. Why is it a silly question to ask? Because you already know how much you've borrowed, which is what? $100,000. But let me ask you this. As soon as you walk out of the bank, this is something that the bank will tell you. Believe me, it will. That you need to pay how many times? 5 times. Right? Right? So you walk out of the bank, you know the yearly payment, and I ask you the following apparently silly question. How much do you owe the bank the moment you walk out of it? You know what many people will say? Many people will multiply 26,380 by 5. And you have just destroyed me if the answer is that. You might as well take a big knife and stick it in my stomach. And the reason is you cannot add or multiply over time because of compounding and a positive interest rate, right? Because if you do, how much do you owe? You owe 20,000 5 times if interest rate was 0. So your answer is not a good one. So here's what you do. You make 26,380 5 times a PMT, right? And what do you make N? 5. Yes? Because you owe 5 of these. What is the only other number you need to do? R, which is what? 10%. If you do this problem, what button do you need to, or what execution in Excel or a calculator do you need to do? Well, to figure this out, you have to figure out PV. Please do it. I wish your answer will work out to be 100,000, right? We know that. Why am I emphasizing this? Because the awesomeness of finance comes from the following simple principle number 1. All value is determined by standing at a point in time and looking forward. You can do value in many different ways. You can do it at time -5 and bring it forward, or do it in the future. But the best way to think about decision making is you're standing at 0 and you're looking forward. So when you're standing at 0 and looking forward, how many payments of 26,380? 5. Each one separated by 1 year. The first one starting in which year? End of the first year. And when you do the PV of it, you better come up with 100,000. And this is one of the most profound Nobel Prize winning points. Please keep it in mind, we'll come back to it later, which is the following. You cannot make money by borrowing and lending. Right? If the present value of 26,380 was different than 100,000, somebody's made a fool of. So suppose the bank gives you more than $100,000. The bank is being an idiot, and let me assure you that won't happen. If you walk off with less, somebody's shafting you. So the question here is, how does the bank then make money? Well, it makes money by charging you a little bit more on the borrowing lending rates difference. They have to feed the family too, right? They work for you. They create the market. But that's the friction I was talking about. But value cannot be created by borrowing and lending. Otherwise, you and I would be home and creating value. Yes, it grows over time, but the present value is still the same as the money I put in, right? That's a very fundamental point in finance. Value is created not by exchanging money, which is this, borrowing and lending. Value is created by coming up with a new idea for creating value for society, right? So that's what I'm trying to say. So let me ask you this. How much will you owe the bank at the beginning of year 2? What would you have to do? You would have to calculate the interest rate, you would have to calculate the principal payment, and then you subtract it from this. Answer is very straightforward. And this is where I love finance. Just change one number. Make this 4. So change the 5 to 4 and do the PV. What will you come up with? Please do it. You will come up with 63280. So what have I done? Instead of sticking with time 0, I have time traveled to period 1. If I'm at period 1, I've already paid this up. How many more left? 4 left. So n is 4 and interest rate is 10%. And how many am I paying? 26,380. So 83,620 is very easy to do if you recognize that. So how would you do the next column? It's 65,603. How will you do it? You'll just make n 3. So you see what I'm saying? What I'm saying is the simplest thing in finance is don't get hung up on the past. Whenever you are asked about value of anything, whether you owe it or you're getting the value, look to the future and the problem becomes trivial. Why? Because if you know all these values, these are just 10% of this. So this is just 10% of this row, and then this is just these two added together is this. So if I add these two, I get this. So I can do this in a second as opposed to doing it over an amortization table. So one more time. If I were to ask you to do this problem all over again, what would you do? You won't use any prop. You only Excel to solve the problem. So if I asked you, how much do you owe in a particular year to the bank, which is a very good question to ask, you will just do what? You will time travel, right? You remember Matrix? Jumps across 2 buildings. First time is not successful, but that's life. But then manages to jump across, right? And if you haven't seen Matrix, see Matrix. It's much more interesting than this problem. So time travel to year, whatever forward, look forward, how many payments are left, just do the PV. Okay? I hope you like this, because this is, if you remember this is finance. Compounding plus this is most of what finance is all about. So it's a mindset. You always look forward, okay? So what I'm going to do is I'm going to introduce the concept of compounding before I do another problem, and then what I would like you to do is do a problem with compounding. So simple interest rate we have talked about. Simple interest is very simple, which is if I give $100,000 to the bank and it pays 10% every year, you get $10,000 every year. But that's not how the world is. Let's do compound interest. Suppose you take the same problem, right? You plan to attend a business school and you will be forced to take out a $100,000 loan at 10%. But now the loan characteristic changes. What are your monthly payments given that you will have to pay back the loan in 5 years? Remember, what have I changed? Have I changed the amount you're borrowing? No. Have I changed the interest rate you're borrowing at yearly? Actually, yes. But we'll see that in a second. The interest rate is written as 10%. The thing that I've changed on you is another real world twist, which I think is important. I've changed the annual payments to monthly payments, and the number of years are the same. So, quick question. What is your monthly payment and what is the real annual interest rate? So these are the two things we'll do, and I will show you how to do this, and I will expect you to understand and do it on your own, but I'll go through the steps, okay? So what has changed? R is 10% annual. But my payment is monthly. So 5 years implies how many months? 60 months. If the interest rate is 10% annual, and by the way, the good news is that's how interest rates are quoted. What is the interest rate per month? It's 0.1 divided by 12. And the reason is there are 12 months. Why is 5 years 60 months? Because there are 12 months in a year. Okay? And what is PV? 100,000. And what are we trying to figure out? PMT. But we are not doing 5 of them. We are doing how many of them? 60. So a lot of people get very confused when the periodicity of the interest payment changes. So you could have monthly interest, you could have annual interest, you could have daily interest, you could have quarterly interest. The way I think about this problem is to remember you are in control. So the best way to deal with this problem is to change the timeline. So do this. Start at 0, put 100,000. Then how many periods? 1 through 60. Why? Because I am doing the problem monthly. What is the interest rate per period? Apples to apples, remember. Take 0.1 and divide by 12. Does it make sense? I am being internally consistent. Why is this a good way to solve the problem? Because the problem is now fits what I know already. So what will happen? Let's go on a spreadsheet and do this problem, and you'll see. So, okay. The good news is I have this problem solved for an annual basis. So what do? I just divide 0.1 by 12. What have I done? I've converted the interest rate to monthly. Then what do? Whatever I have divided the interest rate by, I have to multiply the number of years by the same amount, and it's 60. Right? What is $100,000? Hasn't changed. My interest rate, my payment amount is 2124. So I'm paying about $2,125 per month to repay the loan. So you see what I've done. I've just simply taken the fact that I know that I can mess with the timeline. So I've made N 60. I've made R 0.1 divided by 12, and my PV, the amount of loan, was 100,000. And I came up with, I believe, 2125. Let me just double check that the number is right. Yes, it is. So the question now is, this is question number 1. How many of these will I pay? Obviously, 60. I will encourage you to do one exercise. What is the present value of paying 2125 at that interest rate 60 times? Answer has to be this, the amount of the loan, right? Let me ask you, how much will you owe after 30 months? Right? How much will you owe after 30 months? Very simple. Make PMT 2125, which you just calculated, right? R is what? 0.1 over 12, right? N is how much? Remember, where are you standing now? You're standing at 0.30, looking forward to 60. N is 30. Do the PV of this, you have the amount of money you owe the bank. It's so simple, right? You don't even have to do that whole table. The reason I went through this problem in detail with and without compounding, I mean with annual and monthly, is simply to emphasize to you that it is extremely important for you to recognize that finance is very logical, and you take yourself to the problem and not let the problem scare you. Okay. What is the actual interest rate? How much is my annual R? Actually. Okay? So this is a good question to ask, right? So here's for you to pause and think. The stated R is 10%, but the actual R can't be 10%. It has to be more. And the reason is, again, pause, compounding, right? So let's just quickly do that, and then I encourage you right after that to take another break. As I said, today is a little bit intense, and I want to emphasize, we have done the timeline, the formula, very simple. So what I'm going to do is I'm going to just use this formula and explain. If I put $1 at what interest rate? R is annual, 10%. This is always annual. What is K? K is the number of periods that are within that year. So K is 12 here. Why? Because it's monthly. So how many periods? 12-month period? 12. Raised to power 12. What is this? This number is the future value of $1 after 12 intervals. So what is the interest rate being charged? Is that -1, and I would encourage you to do this calculation, and the answer is you should know this number is greater than 10%. Why? Because you're paying 10% annually, but actually that's not true. You're not paying 10% annually, you're paying 10% divided by 12 monthly. And with compounding, raised to power 12, this works out to actually be about 10.47%. Now, you may think that 0.5% is not a big deal. It is. Especially if you're borrowing a lot of money, it's a big deal. So the difference between this and this, these two, this is stated, and this is actually the real interest that you're being charged. So I hope you take a break now. What we have done is we have taken a loan problem, we have dissected it because it just reflects everything awesome about finance. And then what we have done is we have gone back and said to ourselves, what if we took the loan and we made it a monthly loan? No problem. If you know finance and you are thinking clearly, you're logical, you won't mess with anything except your timeline. So your month matches the period, and if they are 5 years, they are 60 months. The interest rate changes accordingly, and changes accordingly, and then your payment is calculated based on the same kind of information you give. Okay, so I would at this point again take a break. We have a little bit left, one problem left, and a little bit of concept for today, and then we'll call it quits. It's a long day today, but I therefore encourage you to just kind of take a little bit of a break. Hi, welcome back. We have had time and opportunity to do many different problems, and I have taken the time to go really deep into them, and I have spent a lot of time today with you because I believe the value add in online is the explanation one-on-one. And today is a lot of real-world applications which will help you further in the class. So just bear with me for a little time. We'll do one interesting problem, but before we go there, let's do my favorite financial concept. And my favorite financial concept is called a perpetuity. A perpetuity is simply something that pays you C dollars, roughly the same amount, or a PMT, which goes on forever, right? So it's pretty remarkable. So what do you get? You get C, 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 C forever. And it could be with or without growth. So when I saw this the first time, I said, this is nerdy dumb to the extreme. This is a textbook idea. When am I going to ever see something like that, right? So let me just, first of all, think of some examples of perpetuities, right? So there are bonds out there. There is something that pays you, say, £1 for a long period of time. So that's one example. The second example, which is much more complicated but much more intuitive, is what is called a stock. I promise, as opposed to a bond. I promise we'll spend a couple of weeks on stocks and bonds. But I wanted to raise this. What's the basic difference between a stock and a bond? This is limited in maturity, and this hopefully goes on forever. So for example, when John Ford started the company, he didn't say we'll be there only for 5 years and I'll pay you some money and then we are gone. That's not a company. That's not an idea. Great ideas last forever. great things last forever. What I want you to recognize in all of this is that forever actually doesn't mean forever. What do I mean by that? So take the example and show you the power of perpetuities. Now let me ask you this. Suppose I gave you something that paid $10 forever. Guess what the power of perpetuity is? At time 0, guess what its PV is? We won't derive this. I'm going to give you this one formula. When we have time towards the end, I will do stuff that is kind of nerdy and interesting for derivations if you have the time. But I will tell you that it turns out to be C over R. So the simplest formula in the world is the formula for perpetuity, which is the most complex thing to comprehend. So what could this perpetuity be? It's a perpetuity that lasts. It's like a stock that pays you $10 every year and is expected, a company that's expected to survive for the reasonable future. So it turns out, what will be the answer for this? Suppose the interest rate is 10%. This would be $10 divided by 0.1 is $100. Okay? So what could be simpler, right? And would you like this $10 to grow over time? Sure. If it is growing over time at the rate of G is the growth rate. So suppose the growth rate is 10%. So in the first year, how much is it paying? $10. In the second year, it's paying 1.1 and so on. By the way, these things in real life are called growth stocks. So something like what Microsoft was in the beginning, or Google, or technology firms that are successful, they grow and pay over time. Their growth rate is extremely high. What does the formula become? C over R minus G. Right? So because this growth rate is 10%, I can't use this formula. So let's make this growth rate 5%. So what is R? 10%. What is G? 5%. And what is C? $10. Again, very simple to calculate. The reason I'm introducing these now is not so much to start doing a lot of examples. I just want to introduce it now because it's a linear process. We went from annuity, which ends after certain intervals. You take loans and you pay them off. Then you think of another concept that goes on forever, and we'll come back to this stocks. And as I showed you right now, if the growth rate is 10% and your interest rate is also 10%, you can't use this formula. That doesn't mean you can't calculate the number. You'll have to go the long way. That emphasizes one more important issue. Don't use formulas blindly. Formulas are at your disposal, not the other way around. Okay? So we'll come back to perpetuities in the future, but for now I would say just keep it at the back of your mind that there is something real world that looks like a perpetuity, and it's very common. It's what called the share in a company or a stock of a company, because it will last for a very long period of time. And in the real world, what happens is you don't know how to value things beyond, say, 10 years or 30 years. It's just too far because the world is too uncertain. Such formulas, C over R minus G, are really useful in approximating what you think is going to happen. There's no point getting too refined after even 5-6 years because it's about the future. So actually these formulas, when I saw first time, I said, what are they talking about? Are the most useful ones in real life. Because you want to get a sense of value. You don't want to get it so precise when you know it's wrong, right? So approximate formulas like C over R minus G are actually so useful in grabbing the basics of what finance is trying to offer. Okay, as promised, I'm going to spend a little more time today, and this time is not on the next 3 slides. The next 3 slides that you see here, don't worry about them. I'm just emphasizing them to remind myself and to remind you that if you are oriented towards formulas, which I would encourage you to be, because formulas reflect in the end your understanding of what's going on, not the other way around. I would encourage you to walk through these formulas, and as I said, I'm not going to spend the time for you to read them. This is one part of this overhead slides that I've used, or visuals, that I will provide you as a resource. As I said, I want the main resource to be the videos, but I am providing you resources like the course syllabus with chapters from various books written by wonderful people. I also want you to learn from them, not just from me. I don't have the control on learning. Your learning is you who are in charge. But I'll give you some formulas so that you can go back and confirm your knowledge. So just wanted to remind you, and me, we'll do that. That'll put everything together. But I want to end today's class by doing a problem with you. And I would say I'm going to read this problem first with you, try to understand the context, and then I encourage you to take a break. And hopefully you've taken several breaks over different days during this content, because I'm committed in week 2 to make you understand why we do things the way we do. And the reason is we can learn a lot in 10 weeks. And I've taken a lot of time today simply to make you understand how real things are, even though they are problems written on a little spreadsheet or in a little PowerPoint. So let's go through it. You're 30 years old. You believe you'll be able to save for the next 20 years until you're 50. And why am I saying that? Typically, that's when a lot of people earn money and save. But after that, for 10 years, till your retirement at 60, you will have a spike in your I shouldn't even call it a spike in your expenses, many spikes in your expenses, so that you will not be in a position to save for the next 10 years. So remember what's going on. You're starting at 30, 50, and then another break is 60. These are artificial, but believe me, very useful points in your life. After 60, what are you going to do? You want to retire, but you want to be able to live, right? And you want to be able to live at a standard of living which in this problem is pretty high. Because most people in the world cannot afford even 1/10 of this or 1/20th. But I want big round numbers so that I don't have to deal with decimals. And I'm not trying to make a statement about what my expectations or yours are. So you'll retire at 60, and then you expect to live till 80. And you want to take care of the next 20 years at the rate of $100,000, right? You want to, now what is happening now? You were saving between 30 and 50 so that you could do this between 60 and 80. And the fact that both are 20 years is just an artifact of the example. Who controls all of this? You do. Who controls now the next decision? What interest rate will you earn on your savings will depend on you. It'll depend on what type of risks you're willing to take. And for convenience or for just fun, I'm assuming that you are a person inclined to invest in risky stuff. And therefore, you'll be rewarded on average in the long run at 8%. So this is the nature of the beast. This is the problem. I'm encouraging you now to do 2 things. Think about it for about 5 to 10 minutes and do the most important thing in life, which is more important than even finance. I can't believe I just said that. But draw a timeline and put your problem on that timeline. If you can do that, we can do this problem in 5 minutes. If you can't do that, remember, it's not the problem of finance. Finance is going to help you, not hurt you. It's because common sense is not that common. Finance is full of common sense, but the word common sense is a wrong expression. I found whenever I look at common sense, it's pretty complicated. That's why after a while it becomes common to you, but finance is only going to help you. So do that. I'll come back in about 5 minutes and we'll do this problem together, and that'll be the end of today. And I promise you this will enable you to do the assignment and crank up the heat in the assignment. I want this week to be intense for you, and the purposefully so. And the reason is we can go very far. We can go very far, not in the mechanics, but in the understanding of the world. Okay? So break for 5 to 10 minutes and I'll come back to the problem. See you soon. Welcome back. Hopefully you've looked at this problem, thought about it. I want to just emphasize one more time the importance of timelines. So what I've done is actually I've drawn one ahead of time, and I'm going to go to that now. So I'm starting saving at year 30, and for convenience, to be consistent with the formula, we are going to assume that the saving starts at the end of the year. So I'm standing 30, I'll start saving at 31, and I'll quit saving at 50. And whenever I say 31 or 50, it by definition means the end of the year, right? That's the way we talk. I'm going to retire at 60. So what's going to happen between 50 and 60? If you look at the graph, nothing. So what I'm going to do is I'm going to now annotate and start writing on this. So this is the time period when I'm saving. Here, nothing. In other words, by magic, I'm approximately even. I'm not saving and I'm not dissaving. I know you may not have heard of that word, but I have. You're basically not spending more than you're earning every year. It's a matter of convenience, right? And now in this period, what am I doing? I'm consuming, but not earning, right? Again, that's a simplification, but it will give you a sense. I think this word problem is just awesome. You can modify it in various ways. Now the question is, I'm dying at 80. Of course, you don't want to die. I haven't met anybody who's said, you know, I'm really looking forward to dying. But it's one of the most predictable things based on statistics, expected. So let's assume 80, and let's assume for convenience that even in the last year, end of the last year, I'm going to spend some money, me on my behalf or whatever, or given to somebody else or whatever. We can change the problem in many ways. So let's see, what does the question ask me? Is the question asking me how much am I saving per year? Is it a PMT question? The answer is yes. But the problem is the question I'm trying to answer, and this is why finance is awesome and you need to time travel. The answer to it, if you just say PMT to the calculator or Excel and wait, the Excel is going to look at you and smack you around, and rightly so. Saying, you expect me to answer a question even I don't know the answer to, right? You Google PMT, the Google is going to laugh back at you. So the question is, you've got to know something in the future. So yes, turns out we do. We know from 61 to 80, what do I want? I want PMT of how much every year? That's what I said, we have everything set up. We want a payment of what? We want, if you go back to the problem, let's go back to the problem for a second so that we are all on the same page, right? I don't want to confuse numbers. I want to consume $100,000 every year. So once I know that starting year 61, I need 100,000. And how many of these? 20 of these. So this is a very simple problem to do. It's called a PMT present value problem. So I do the PV at this point. Let's do it very quickly. Because if I know the PV at this point, I will know the PV at this point. If I know the PV at this point, I know the future value of my savings. So the thing I'm trying to solve for is 20 PMTs here, which is money I'm going to invest. And the answer is hidden in 20 PMTs in the future. The only difference between these two is a difference in time. And obviously, in one case, I'm giving away money to the bank or a fund or retirement account. In the other case, I'm withdrawing, right? Okay, everybody? So let's do. If I can somehow figure this out, I'll be much better off than I am right now. So let's try to get to it. Okay, Excel. So this is not a PMT problem. I know the PMT. So what am I going to do? Please recognize you've time traveled to year 60. Why have I time traveled to year 60? Because I know how to figure out the present value of something starting 1 year from now. And at 60, I know 61, I'll need 100,000. Okay, so the interest rate, and we are doing this annual, so we don't want to do the monthly thing, is 0.08, I believe, right? And how many periods? I have 20 periods. And what is PMT? Turns out it's exactly the same number from the previous problem. So 124,909, 124,000, and there must be an error here. Let me just try to make sure we got it. Yep, I could tell there was a mistake. When I did it quickly, I pressed 0.8. And 0.8 is 80% interest rate. You don't want that, right? Okay, this makes a lot more sense. So I have 981,814.74. I'm going to go back now. And say that what I need is 980, and to confirm the number, 981,815. Write it one more time so that it's legible. At what point? This is the PV at 0.60. Another way in English to say this is the following. Remember we did the loan problem and we talked about repaying the loan? It's the same problem, except slightly different. I need to have $981,000, about 982 if you may, in the bank. In which year? In year 60, to be able to finance what? $100,000 worth of consumption every year, withdrawal. And at the end of year 80, how much will I be left with? 0. Exactly the same problem, right? So that's what I want you to understand. In the end, there's only one problem. And if you know how to do it, you can apply that thinking to anything. However, I have a problem here. There's a gap of 10 years that I don't like. Why? Because I know how to use annuities, but I do not know how to use annuities that end in year 50, but actually the valuation I know is in year 60. So what do I need to do? Step 2. And by the way, you can do this many ways. I'm taking the easy way out. So what do I have to do? Remember, in finance, time value of money is everything, and the interest rate is what? 8%. So now what do I have to do? I have to bring it back PV in year 50. What will that do? That will become the future value of the saving annuity I'm trying to solve. So let's do that, and that will help us. As I said, this is a very, very cool problem, and I'm going to walk you through it simply because I'm going to make another cell. Notice I have left, okay, notice I've left the first cell still open, and I'm going to write I'm going to write equal, and now I'm going to do a PV function, right? And you'll see in a second why I have left that cell in its own place. Because I can write 0.08, the interest rate is 0.08. Remember I screwed up last time? I put 0.8, don't do that. Number of periods 10. Why? Because I'm bringing a value I know in year 60 back to year 50, right? And there is no PMT. Remember, this is a one-shot thing. So we are combining our learnings from the past week. There is no PMT. It's a one-shot bank account that will finance a future PMT, right? So 0, don't forget that. And then I know the future value of this. Where is it residing? In cell A1. So what is the value of 981 year 60 in year 50? Well, the value is about $454,000 and 770. So I'm going to, I apologize, there's a little bit of going of this. Let me just write out the numbers. So it's about 981,815. I have now brought it back to about 454, and to get the numbers right, 770. I'm just confirming that the numbers are right. Okay, so let's see what has happened. The magnitude, it's almost become half, right? Actually, less than half. And the reason is I'm discounting heavily at 8%. Now I'm almost done. Why? Because this PV is in year 50, this PV is in year 60, but I know if I know this PV in year 50, it can become the future value of this problem. So I know the value that I'm saving towards is about $455,000, $454,770. But now I need to ask the following question: how much every year will I put in the bank so that I am sure $454,770 is there? Everybody got that? Right? One more step. Okay. So now notice I'll keep that 454 exactly where it is. One, it will give me a sense of what I've got the right numbers, but now I want to do what? Remember, I'm trying to save every year an amount that becomes 454 after 20 years. So I'm going to do a PMT problem. Why? Because I don't know the amount. Okay, what is the interest rate? 0.08. How many times am I saving? N period is 20. And what is the present value of it? I don't know the present value, because the present value would be in year 30, right? So what do I do know? Luckily, I know the future value. And where is it sitting? In cell A2, right? Bingo. 46,319. And let me just confirm that this is okay. And turns out this seems to be too much. So what did I do wrong here? A1, A2, PMT. You see what I did wrong? And I wasn't paying attention. I pressed A2 as PV. It's good to make mistakes, which I know you will, but it's a minor mistake in the sense that I'm making a calculation error, but I could guess my answer was wrong because it was too high. So I have 9937. So the answer now is right. Remember, if you look up and you do the PMT function, the first number you press is interest rate, second is number of periods 20, the third is PV. And I said I didn't have any PV, but I didn't put 0. And final is FV. So if I knew the PV, I would replace 0 by that and make A2 0. Is that so? Okay. So we are cool now, and we know, and I'll confirm, that we need 9938, and we are almost done. So here comes the final. I'm sure you're relieved by now, but how much would I save every year for the next 20 years is 9938. Look at the awesomeness of this. Look at the awesomeness. In this case, the awesomeness of finance is helping you. It's actually really not, because it's time value of money. But I am saving only $10,000. How many times? 20 times. But I'm going to use that money to consume how much? 20 times. $100,000, 20 times. How the heck is this possible? It's possible because the time value of money is 8%. If the time value of money was 0, the world ain't going to make me do this easily, right? So I save 9938, I get 9938 back, 1 for 1, if the interest rate is 0. I hope you liked today, because I loved talking to you today. I'm not kidding you, which, by the way, kidding in the US means making fun of you or joking with you, and because I've traveled and I've lived in different countries and different words mean different things. But I've tried to tell you the essence and the beauty of finance, which has made it a little bit challenging for you, I'm sure. But I think that's the value of this class, if anything, I have to bring to the table. Just a quick minute. I wanted you to know that I feel very fortunate that I'm able to teach you anything at all. And many times I want to be like Tuvok. I hope you watch Star Trek and so on and do the mind meld and do this very quickly. But that's not feasible, right? And that's also probably not the right thing to do, because if you try to gain knowledge very quickly like that, it tends not to stick. So I've tried to make the problems real world. I've tried to go slow with you, and therefore the videos will be long. When will the videos be short? When the content is very crisp, but maybe you need to go to a textbook to reinforce. Or maybe you need to go back later to accounting to reinforce, or statistics. See you next time. It was fun talking to you this week. And I hope you stay in touch and do the problems, in touch with the material and do the assignment. See you next week. Thank you very much.